Welcome everyone to our workshop this afternoon on market pathways for cloud edge IoT in the energy sector. The workshop will be recorded, so if you don't want to see your face, turn off your camera. Yeah, I'd like to welcome you in the name of the whole UNLOCK-CEI consortium. UNLOCK is a communication and support action funded by the European Commission that aims at unlocking the potential of the deployment of cloud edge IoT technology. We're looking at this challenge sector-wise. Today, we're looking at the energy sector, and part of our job is also to bring together different stakeholders, support research projects that are also funded by the European Union, in particular the Meta Operating Systems, Meta OS project that you will also be hearing more about later today. So what are our topics today? First, we want to look at what are market pathways and opportunities for SI companies in the energy sector. Get to know and discuss innovative SI solutions, and look at data sharing, if it's ready, where it's necessary, and also open source potentials, and hopefully somehow in a small way enable the energy transition as a whole. So a quick look on the workshop agenda. First, I will do a short presentation of results from our analysis in the project. By the way, my name is Hannah Funk. I work for VDI IT. Then we have a range for great experts that will tell us a bit about their solutions, and you will be able to ask them questions, and then we will have a joint discussion. After that, there will be a range of use case pitches from the Meta OS portfolio. And then we also have a moderated discussion on possible market scenarios and pathways for the European site technologies. So, okay, let's dive in our analysis in the project. You all know this, we come from this linear energy value chain where the energy is generated, goes into the grid, the market, and the energy user or the consumption. Now, with flexible and weather dependent and decentralized energy sources, there comes a whole bunch of new challenges, and the directions are no longer in one direction. So we tried to update it, but somehow this doesn't really work for the challenges we have, because evolving stakeholders, like, for example, the prosumer, would be in energy generation as well as energy consumption, and doesn't really fit into those categories. So let's look at it as from the challenge point of view, that we now need to shift our energy consumption or generation flexibly to another moment and or location. So what we need for smart grid and energy management is flexible integration of energy sources. We need, of course, stability and resilience, and efficiency. And these can be achieved mainly by the following approaches: market flexibility and or technical flexibility, and active network management. So if we translate that in a figure with the stakeholders, we came up with this non-linear energy value network where we have the evolving stakeholders like energy suppliers, and we also have the emerging stakeholders that in some parts use aspects of the market flexibility also, or the technical flexibility, and also here of course things are usually blurry, but all of it is embedded in an active network management where cloud, edge, and IoT infrastructure play a crucial role. So as a next step, we looked a bit closer into those, the on-device IoT, micro-edge, on-premise edge, external network or far edge, and cloud, and developed this taxonomy of building blocks of cloud-edge-IoT computing continuum. What can companies actually be doing to enable this? So we looked from the CEI side, sort of. And then we did a mapping of energy sector specific players, but also cross-domain players onto these building blocks. Many players provide both or several building blocks, not all of them, some are very specific. And now I won't bore you with 30 slides of company names, but rather with the results that we drew from this analysis, which we also did some more interviews with more innovative companies in the energy use case with a company called Tibber. It's a digital energy company that provides electricity and assists customers in minimizing their energy consumption or shifting the usage to periods of lower electricity cost. And we also talked to Crosser, which is a platform supplier, cross-domain. And our conclusions from both the mapping of the existing players on the market and the interviews with innovative CEI companies was that the big tech players and hyperscalers like AWS, Microsoft, IBM, and so on have focused in recent years rather on cloud-centered services. So opportunities for European companies are really to fill the gap of edge computing services. We found a wide range of CEI companies that are active in the energy sector. However, something that isn't solved really is data sharing for innovative solutions. I mean, we have the Data Act that will be coming into place, but still there's a lot of open questions on who has access and ownership of data in European markets. And then, I mean, I guess that's the standard of digitalization in the energy market. There's a backlog of digitalization in the grids, transportation system operators, as well as distribution system operators. That's, well, slowing the potential for transformation. And from these results, we also, and especially this data sharing issue, we took a look at the existing national data hubs. Several European countries do have established some form or other that should facilitate data exchange and communication within the energy sectors. Many of them are run by the transmission system operators because they just tend to have quite some data. But in other cases, like Austria, for example, it's an Austrian regulatory authority. And I'd be curious also if you know of them, if you think they're useful, and so on. So we really come to the next point, what's up for discussion. We would like, or also in the invited talks that we have, which are mostly edge platform providers for system integrators, you will see some examples of innovative cloud edge IoT products. For the energy sector, what's their solution? Are they disruptive? We would like to look into what business models are and governance structures are there that drive open source solutions, and what level of data sharing is necessary for solutions, and are SI and energy markets, as well as users and regulation, ready for it. So I would like to introduce our 4 speakers that we have coming up. We have Wilbert Prissen from Technolution, a Dutch company that, and I think he will mainly be talking about sensors for distribution system stations. But I mean, he will be talking and know more than me. We have Robert Deleuve, who's working at Pionex, but pushing the open source solution Everest for electric vehicle charging protocols. We have Professor Henrik Madsen that's using algorithms to connect the market or the available energy with an end user, and Blaine Mathieu of Frataxto, that's a platform provider, for example, for DSOs. So let's maybe also go in this direction, start with Wilbert, then go to Robert, Henrik, Blaine, and I'll stop sharing and give the word to Wilbert.
Thank you, Hannah. I'll try to start sharing them. And
go ahead.
You set the bar high because you said that I would know more than you. I'm definitely not sure about that, but I'll hope to entertain you with some.
Definitely more about Technolution solutions.
I'm sure about that. I've prepared a presentation on some edge cloud use cases that we're working on, mainly in the energy field, maybe as a guidance for how can you find business models in the energy sector, and what's hampering us, or maybe what are opportunities. I'll briefly start introducing Technolution, but not too long, I hope. Then say some words about how we see edge technology and what architectures, horizontal architectures they fit in. And then I'll go into a few reference cases. And yeah, I would gladly answer any questions or go into any dialogue. So Technolution is a company in Gouda in the Netherlands, started in 1987 with 4 technology passionate people. I'm sure they had color pictures then, but we have a black and white here. Now we're 250, and we're still very much focused on electronics, technical software, and fun things that you can do with those to connect digital and physical worlds. Also, Face2Face is a daughter of us, and that's a market leader in the Netherlands in digital twins for energy calculations for electricity grids. So we focus on 4 different markets: mobility and infrastructure, and security, high-tech industry, and I am myself responsible for what we do in the energy market, which is focused on both DSOs and on energy users, so industry. Well, edge technology and horizontal architectures, what do we generally see? If we come into a DSO or an energy-intensive industry, there generally already solutions available. So you're not starting from a blank slate, because, well, with me here, the light is on, and with you also the light is on in the different rooms that I see. There are operational systems there, and that's good. Generally, those systems tend to be, let's say, monoliths, vertical architectures. For instance, for SCADA PLC systems within DSO grids, but also in industry for all kinds of process control, where we see that the physical world of, for instance, electricity grids is connected to business applications in quite a closed vertical stack with one supplier generally. And this has many advantages for our customers because it's easier to acquire, and when you've bought it, it's clear who's responsible because there's only one vendor. Generally, it's proven reliable because many SCADA and other systems have quite a wide reach globally. The downside is that the innovation is generally slower, and there are hard lifecycle issues if something, for instance, a box or a telecommunication standard, has to be updated. Generally, you have a problem. So what we often propose as technology integrators to think horizontally. So think in different layers. In this model, we see 9 different layers between the physical world and the digital world, which can all be, ideally can be bought independently from different vendors. Some of those layers are quite generic. For instance, wide area communication is a very generic theme, or central data platform. There are quite generic solutions for that. Some layers are very specific. For instance, sensors or actuators are very business specific, and edge or business applications as well. Well, and the edge is not just a box in our philosophy. Also in the edge domain, you can still separate data platforms or processing power from actual sensors and actuators. These architectures also have some great advantages because per layer you can use the best-in-class technologies. Per layer, it's easier to lifecycle. For instance, if you change wide area communication protocols, you generally don't need to fix everything, but just exchange modems. You can do faster iterative innovation. For instance, you can just update applications instead of updating complete hardware solutions. The downside is, especially from DSO or other end customer, you have much more integration efforts and risk. I mean, if something doesn't work, well, where is the problem? Who should you call if you have 9 different vendors? For us, as technology integrator, we don't see this as a downside, but this is our work and this is what we like to do. So in terms of edge cloud continuum, the way we would see this really working well in innovation is if you say that, for instance, there's lots of new data available and there's a data scientist, shown the data science sandbox here on the top right, who's doing great stuff with new data that he's found in a sensor, and he's doing that in some kind of statistical suite, or he's running his own Python libraries on it, and he finds some great pattern or something that's really interesting for his business. Ideally, then you could industrialize what he's done on his desktop into a business application that runs on the cloud. But if that business application is quite successful, ideally you just pick it up and port it towards the edge. I mean, if you have some container technology like Docker, for instance, ideally you just pick up applications and put them anywhere on the cloud edge continuum. Those are architectures that we're trying to strive for. Well, why would you put stuff in the edge? Because generally the cloud is cheaper, easily available, easy to maintain. Well, there's first of all, there's a drive to go towards the edge. I mean, Moore's law just makes compute and memory cheaper everywhere, so also for edge computers. Well, look at the proliferance of Raspberry Pi, but industrial PCs are really quite powerful, or RTUs, with generic PC capabilities, and they're very wide available. Why would you then do it? Well, for instance, you might want to evade all kinds of communication, especially if you have lots of data to process. Or you might want to be locally autonomous. You want to have a control that is not hampered by a failure of an internet connection. Privacy is a driver for edge computing, and also data ownership might be an important topic. I'll go into these three topics in different reference cases. So first of all, and I think that's the main topic for today, what can you do with data analytics in electricity grids? So this is a project that we did with DNV a few years ago. What you see here is a product that's called Smart Cable Guard with a sensor and a control unit box, which has local analytics. And what it does, you put the sensors on both sides of a mid-voltage cable. The cable goes underground for 1 to 8 kilometers generally. And when that cable is breaking down or partially discharging, you can see a pattern from that discharge. And when you really very narrowly monitor that pattern, you can see that the cable is degrading, but you can also see where it is degrading if you have good time synchronization. This product is now, I think, installed many thousands of times throughout the world by DNV, which I think is a great example of powerful edge case. Further into digitization in substations, well, like I said, there are generally very proven solutions there, like protection and control systems that keep the stations up and running, and you don't want to mess with those. So coming in with all kinds of IoT, nice new innovations, people there tend to be conservative, and rightly so. But how can you still be innovative and try to find new use cases? Well, what we are doing here with Alliander and subsidiary of Alliander, Locomation, we have developed voltage and current sensors for these 50 kilovolt substations. And those sensors have open protocol 61850 sampled value streams, and they stream their measurements openly to those station protection and control systems and use them for protection and control, the classical control room. But what you can also do with this open interface, these open data streams, you can add an edge platform next to that. And you see maybe the symbol of a diode here. There's a data diode which ensures that data can only stream from left to right. So you can ensure physically that there is no cybersecurity risks there. The data can only come from the left to the right. And on the right side, you have possibilities with an edge platform. It might be a server or an industrial PC. We chose a powerful server here to analyze all those high frequency data streams. Those are 60 kilohertz samples of powers, of currents and voltages. And you can do all kinds of apps. Those apps can be from third-party vendors, and you can run those apps on quite open source infrastructure, like, for instance, Linux Foundation for Energy Flash platforms. We have open software buses, either 0MQ or MQTT, and then run Dockerized container apps. For instance, power quality analysis or asset monitoring. Is a cable going to break down? Fault analysis, and hopefully we might even do stuff around thermal congestion. Can you see that cables or transformers are heating up? Well, in the edge cloud continuum, then, this is quite high data sampling and analytics that you do locally. You don't want to have all those data streaming up to a cloud, because essentially you're almost streaming Netflix there. But still, in a central control room, you would want to know whether there's cable degradation. So you send only the information derived from those advanced analytics to an addition to those central control rooms. And this is what we're doing with Delft University in the Control Room of the Future project. So all open elements in the chain here. This is, we're doing prototype and proof of concepts with DSOs and universities here. I'll go a bit faster through time. You see, it's a bit, I'm a bit slow. AI for smart mobility. Well, of course, it's electricity here, but I want to show you this briefly because I think it's an advanced case of really neural networks in edge systems. What we did here is build a video camera in a little box. This is the Rotterdam Central Station. And what we see is bicycle and pedestrian traffic. We can monitor that. Well, nobody wants to be caught on camera and streamed throughout the municipality. So all processing of those camera images is done locally. What you can see is how many pedestrians were there, how many cyclists, where did they go, what were their routes, did they wait for the red light or not, is that an issue? In the back end, there's only information, no privacy sensitive issues, but very worthwhile information because you know traffic streams and you can also control them. We are also looking at more advanced use cases. So when there's a camera there, you can also see that an accident has almost happened, still without privacy incursion. So you don't stream those data to a central cloud, but you can say this is a dangerous crossroads. You should do something about it. And the final case that I want to briefly show you is an initiative by the Dutch DSOs that are now changing the smart meters. The classical smart meters were quite closed boxes, closed stores, and also one box to suit all. Well, more horizontal approaches to make it more modular, which is what they're doing in the next-gen project. One of the main drivers was that the current modems or the current telecommunication, the GPRS and CDMA are outdated, so they should change that. And with the current design, just to change the modem, they have to change the entire smart meter. In this new design, they make it interchangeable, so the smart meter stays. You don't have to do anything with the dangerous high voltage installation in your house. You just have to interchange the top box, which is where the modem and also processing power is. Well, in this concept, not only the hardware should be modular in our view, so we also did a demonstrator with DSOs and with the TU Delft, where you could also do modular software. So we made an app store also for the residents in the house and tested that at the TU Delft Green Village Living Lab. So every household, so in terms of federated data architecture, all data lives on the smart meter, so very locally in the energy system, no central data lakes. And this smart meter is a place where then the residents of the house can install apps. And with those apps, they can give access to that data for all kinds of different use cases. A bit similar to how you can give apps on your smartphone access to the camera or data or whatever. And with this, they are enabled to, well, make the data available in their house. So we did a pilot on the bottom right with in-house appliances, domotics. You could share the data on apps through energy providers. Well, you can already do that now, but now it's under control of the residents. And on the bottom left, an actual use case is giving that data also to the DSO to run their grids well. Also, again, privacy compliant. So, yeah, I hope that you found it interesting. I gave some of the pilots that we are now doing in Edge with energy and electricity. And, well, it's an interesting time to do these projects. We're coming to value slowly. I'd be happy to take any questions or receive any comments.
So thank you very much for that great overview. We have a first question in the chat, which is for the smart meter data governance. Is anonymized data still available to the DSO? Well, you basically answered that. Is there any incentive to share more detailed data with DSOs?
Yeah, so we're looking at it in two separate directions, so or maybe three. You could say the DSO should be entitled to see the data anyway. We didn't follow that direction here. We said, okay, you enable them to view it.
Mm-hmm.
And there are two types of enablement. One is the not so privacy sensitive data, especially voltages. So voltage monitoring is a lesser strict regime. The actual power is much more privacy sensitive because that would say something about whether you're at home or not, whether you have a waterbed or not. So you could either share that directly, or as an intermediate form, we have developed a multi-party computation app, which encrypts that data so that it can only be used in an aggregated form. So that's an advanced mathematical technique. And I think that is the key use case of such a localized edge infrastructure, because with that technology, you can ensure that no privacy data is seen by the DSO. And in the meantime, well, it is still very valuable for the DSO to run the grid because they're not interested in your house. They're interested in the entire cable or the entire municipality.
Mm-hmm. Yeah, very interesting. And well, I don't know, I guess that's the issue of regulation again. Is there any incentive to share more detailed data with the DSOs for the end users? I would say not yet, but yeah.
No, those schemes to share data or even to curtail peaks, they're very limited still in the Netherlands. But on the other hand, I'm not sure if the incentive to share data is so needs to be so large, because if you appeal to the common, so what happens now currently with smart meters is that you somehow people have the perception that they have to share no matter what, and that they're really privacy compliant. We found, and it's not statistically significant on the scale of what we did, but I have a belief there that if you give people the option of, okay, you could share at no loss to you your data for the greater good, please click here and you can switch it off anytime, that people are inclined to say yes, because it doesn't cost them anything and makes them feel good about themselves that they helped the greater good.
Okay, thank you. So the whole DSO data topic, I think we can discuss much longer and maybe also later together. But now let's thank you again, Wilbert, and give the floor to Robert for his presentation.
Thank you. Thank you, Wilbert. Always impressive to see the stuff that you guys at Technolution are doing. Screen. Hi, welcome everybody. I will start with a bit of introduction on what is EV charging very briefly, so everybody at least knows what we're talking about, then a bit on Everest, the project that we're doing, and then I will end with a bit of describing our company Pionix and what we hope to achieve as a company. If you think, hey, he works for a German company, why does he sound so Dutch? That's correct. I'm Dutch, but I work for a German company. EV charging. To charge an EV, you need a vehicle, and to charge that vehicle, you need a charging station. There's a lot of different protocols between the vehicle and the charging station to get communication working. Typical charging stations are managed remotely via the cloud, via OSPF, an open protocol that basically everybody in the world nowadays uses to manage charging stations. And the OEMs typically also have cloud connections to their modern vehicles, for all kind of additional services. Yeah, if you do EV charging stations, that means there's a lot of standards that you need to comply to. And now I'm only talking about communication standards, but there's also a lot of safety standards and regulations that charging stations need to comply to. The amount of protocols and standards is growing. Almost every year there's new versions of standards. There's additional standards coming out. A lot of these are on the communication between the vehicle and the charging station, but also to connection to the grid. There's new standards. There's new standards for home automation to integrate home chargers to home energy management systems. This means that if you want to build a charging station, you need to develop more and more software. Companies making charging stations have basically a couple of options. Either they build everything themselves. So what you see on the left here, at the bottom left here, somebody builds their own charging station, their own stack, or they might buy one component from another company, or they might buy different components from different companies and try to match those together and make it work. This causes interoperability issues within the charging station. There's a lot of variance in the implementations of the different protocols. A lot of software developers are basically developing exactly the same software as everybody else is doing. It doesn't bring them any value. It's just commodity software. And it also makes operating charging stations harder because they don't respond the same to the same commands. Now, we try to solve this by making one shared code base. We believe that with Everest, if every charging station is using exactly the same stack, then charging station manufacturers only need to add their own additional unique selling points and don't need to worry anymore about all the standard protocols that they should have implemented to make a charging station work. One of the biggest issues that we see at the moment with charging stations is there's just way too many different combinations possible. There is a lot of different charging station manufacturers. We estimate at the moment at least 250 worldwide. At least half of them develop their own software. The other half might buy a full stack or parts of a stack from somebody else. On the other hand, here on the right, we see the EVs. There is more and more EVs coming out now every week. When I started in EV charging 11 years ago, oh, there's a new EV coming out in half a year. That was big news. Yeah, you could try to organize a test with that. Nowadays, there's a new EV coming out every week. And probably within 10 years, there's a new EV coming out every day. As a charging station manufacturer, you can't keep up with the vehicle manufacturers. And as a vehicle manufacturer, there's way too many chargers out there to test with. This becomes impossible to test. Now, then also on the cloud side, there's a lot of different cloud implementations. Also testing those means a lot of effort, a lot of variance. Yeah, we really believe we can solve this problem by, next slide, having one charging station software stack that works the same for every charger. That means it's way simpler to test. And we also believe that this can't be a monopoly from one software company. This needs to be a cooperation between a lot of different companies. And this has to be open source. This is the reason why Bionic started Project Everest, is to make this single software stack available for the entire industry. Now, what's the advantage of open source? Yeah, we can solve a lot of incompatibilities. We give people access to software. They can test with this easily. They can incorporate the same software stack in all their products. We reduce a lot of development effort that otherwise is done to just develop commodity code, which doesn't even bring value. It's way slower to innovate without open source because you have to do all the standards. If you are relying on open source, you can really focus on your unique advantages or new features that you want to build. And by staying with standards, but also making it open source, we won't have the problem of broken assets. There's already stranded assets with charging stations, charging manufacturers going bankrupt. They won't maintain their chargers. Nobody can update the software because they don't know the software. With open source, somebody else could just start making software for those chargers, and those chargers could still be maintained without having to replace the chargers, which in the end is not so sustainable. Then a bit on the Everest community. So if you do an open source project, Pionix made the decision to not put, hey, this is our project, let's put this on GitHub and now it's open source. That is true, but a real good open source project should be managed by an open source community. And ideally, this is done by an organization like Eclipse or Linux. We went for the Linux Foundation Energy. Wilbert already mentioned one of the other projects in Linux Foundation Energy. Linux Foundation has a technical advisory console. They basically review all the projects that want to become part of Linux Foundation. They facilitate a lot of collaboration between the projects, but also try to standardize processes and procedures to make sure that all the open source projects are maintained in a correct and fair way. Now then on the project side itself, so on Everest, every project within Linux Foundation needs to have a technical steering committee. For us, that means we've set up the project, so we are still the main maintainer of the project. But nowadays we have 4 other companies already active in the technical steering committee. The one that we're most proud of at the moment is the Joint Office of Energy and Transport. So since 2 months, the US Joint Office of Energy and Transport is actively contributing to Everest. There's a big fund from the US government to get new public charging infrastructure installed. The Biden administration has assigned the task to the Joint Office to review all the requests for funding and also to make sure that it is possible for charging station manufacturers to comply to the requirements. And the Joint Office has chosen to use Everest as their reference platform. So they are now making sure that Everest can comply to the NEVI requirements. So they're actively contributing to Everest, which we are very proud of. Gives us a lot more people that start using Everest and also start contributing. Then a bit lower level within Everest itself, there's so many people now contributing that we had to split up our work in different working groups just to be able to have all the people that work on a certain specific topic to focus a bit more on their own work. One group is focusing on all the communication protocols to the car. One group is focusing on all the communication to the cloud. One group is really focusing on testing and build pipelines. And then we have one group that focuses on the framework of Everest itself and all the tools around Everest. Now we see the community growing and growing. With Everest in the middle, you see on the top left here is Pionix, the Linux Foundation, of course. We are active in a lot of standardization bodies, the different bodies that prescribe the protocols for charging and for maintaining the connection with the cloud. But also we are actively working together with Trusted Computing Group to make sure that Everest is up to the highest security standards. Because in the end, a charging station takes quite some power from the grid. Someone is able to hack a lot of charging stations. That could cause huge issues to the grid. We also try to work as much as possible with universities and research centers. So we have quite a good relationship with especially some German universities. There's some students doing security reviews of Everest. One of the advantages of open source security reviews can review really the source code, which makes things more safe. And then on the other hand, we're also actively working together with component suppliers that use Everest as their reference implementation already for their chipsets or their components. And we have quite some active projects that we as Pionix do to get Everest into their projects. So the community is quickly growing. Everest started 2 years ago and quite some traction already. Currently, we are the most active company with project within the Linux Foundation Energy. And then Pionix itself. So Everest is the open source project. Pionix is the company that started this, and we want to become a sustainable business as well. We make open source software, we give that away for free. We still need to earn money in the end. And we try to do this by providing a corporate grade version of Everest, where we also provide professional service on top of that, and then sell maintenance contracts to companies that want us to maintain the software, so they don't need to have software engineers that do that. That's our business that we are trying to set up. So, but yeah, as I said, we've been founded 3 years ago. Our founders had a company before, and when they sold that to Intel, they started looking for where can we make an impact in the industry, and that's when they started Pionix. Nowadays, as of today, exactly today, in our hall, there's a big crowd of charging station manufacturers testing their chargers with different backends. So we've had a busy week here in Germany. We also make open hardware. We needed the development kit ourselves to develop software on. We made this all available as open hardware as well. So we have all the PCB layouts, all the Gerber files you need to make a PCB, the BOM files, but also even the housing. We made it all available as open hardware because we believe this is useful for the community. Yeah, people can also buy them from us, but they can also buy them themselves, build them themselves. Yeah, the question was also a bit on data sharing. If you look at the industry, typically the OEM is sharing data from their vehicles and they own that data. The charge point operators, they get a lot of data from the charging stations. There are CPOs, and it depends a bit on which country they are in, that are also sharing data with governments or universities for research. I don't see the CPOs sharing that much data with the TSOs at the moment, but as soon as more and more smart charging is being active, I'm convinced that they will need to share data, because if you want to influence charging to help the grid, help support the grid, the CPOs need to work closely together with the TSOs and DSOs. There are some charger manufacturers that are sharing data with their own telematics data channels. Those are not that common. We as Pionix are now setting up our own platform to provide customers, our customers, if they want to, also to get telematics data from the charging stations running efforts. And we don't foresee at the moment that we would do data sharing with third parties, as this is data then owned by the charger manufacturers, and we are only facilitating the gathering of the data. Yeah, if you want to know more, get in touch. That was it from my part. Any questions?
Nothing so far in the chat. If there's someone with a question, also please just raise your voice. Okay, Mark, go ahead.
Yes, sorry. Thank you very much, Robert. I didn't see in your presentation any discussion of how the charging points, typically the public charging points, are communicating with the charge point operators or other parties. You weren't discussing the typical kind of network and communication capabilities. So could you describe that a little bit, and also the level of intelligence that's being provided right at the charge point? You know, how much work can be done on board?
Yeah, it depends a bit on, so the processing power depends a lot on the type of charging station. They go from quite dumb or almost just power sockets to high power DC chargers that can do hundreds of kilowatts, including battery storage to reduce the load on the grid. Those tend to have very high processing power. Typical processing power we have, roughly something like Raspberry Pi is enough to run Everest. We run Linux. And on that, we can do quite some energy management solutions as well. Then the communication to the CPO, the charge point operator, that's typically OCPP. Most public chargers use 4G networks, wireless networks. If they are in parking garages, sometimes wired within the parking garage, and there may be a modem outside. Home chargers, as far as I know, typically if there's a broadband connection, ideally you want to hook them up to the broadband connection at home and not having to install an additional modem inside the charging station. As I said, the protocol to manage charging stations worldwide is OCPP nowadays. A protocol that was started in the Netherlands by EUCloud, which is now really worldwide standard. There's no as far as I know, no charge point operator anymore that is not using OSPP. I think the last of the Mohicans that wasn't using OSPP was Tesla. They're now also implementing OSPP. They're now also part of the foundation managing OSPP. So they're also actively contributing. Does that answer your question?
We have a thumbs up. I have another maybe slightly geopolitical questions. Like now this endorsement of the US Joint Office really put you up in numbers, right? Would you, I mean, what gremium would you want from Europe, for example? And actually, what about China? That's putting one car after the other on the market and so on. How's that?
China is an interesting one. There's a lot of chargers slowly coming from China as well. And we do see that the interoperability problems with those chargers at the moment is higher. Partly probably because the developers don't have access to the vehicles that we have in Europe. They can't import the vehicles with the same connector. There's a different connector and a different standard to talk to vehicles in China than there's here. So any vehicle in China doesn't work with the protocols that we use in Europe or in the US. So on one hand, we would love to see the charge also use Everest, because that would probably improve reliability a lot. I just was in contact today. As I said, we have a big test event here in our office. There is somebody from China that is working on an open source implementation together with the Chinese government project to work on an open source implementation of the Chinese protocol. So we really now made contact on how can we get this into Everest as well, to really make it a worldwide standard, which would enable companies from everywhere to also make chargers that work in China, because the Chinese standard is written in Chinese. There's probably not that many people in Europe that can read that then.
Yeah. Okay.
What
so
kind of endorsement? And the other part of your question was, what kind of endorsement would we want to have from? Would we love to have from the European Commission, from the European Union? I think the thing that's lacking most for the industry at the moment is Europe asking for OSPP. So currently, the request is to make charging stations, but one of the problems that we run into is that OSPP is an industry standard and is not defined by a standardization body. And our European regulations say that there's no government that could require a standard that is not from an international standardization body. So a lot of countries are saying, yeah, you have to install chargers and they need to comply to the standard, but they can't put in OSPP at the moment. So there's a lot of politics currently involved, and I'm not involved in that directly, to try to make OSPP an IEC standard. And that's a slow process at the moment.
Yeah, okay, that's interesting, because I thought that mainly you need industry to back your solution, but you also need regulation to back it in the end, somewhat.
No.
Okay, very interesting. Thank you, Robert.
Thank you.
Maybe later we have time for more questions if people come up with them. But for the moment, I would invite Henrik to start and share his slides.
Yeah, thank you very much. Now you should be able to see my slides, I hope. I'm from the university, and I'm a professor in applied mathematics and AI, mathematical statistics, and things like that. But my group, we formed a number of companies working in the energy domain. But of course, I will mostly here, I will not really mention these companies. We can come back to that. But I will have a rather high-level presentation, which zooms in on how we can use this cloud-edge-IoT solution to accelerate the green transition and solve some of the challenges we have in the energy systems hierarchy. And one thing I would probably like to touch upon here in the beginning is that there is a tendency to talk about electricity grids, we should realize that in order to really fast forward the green transition, we need to consider the entire energy systems. And one of the problems we have with standardization also is some of the standards are for designed for electricity sector, where it should be fast, but district heating, we have a lot of district heating. Denmark is a slow energy system, and district heating is a very nice system for balancing wind and solar generation. So we are using we are using very much the minimum interoperability mechanisms, which are now coming into standard and so on. So I'll touch upon this. So and of course I will also say that the solutions we have I will end by showing, I think, 3 or 4 different solutions which are implemented as actually a European, now it's a European digital innovation hub for this type of solution. So of course you all know there is a tendency that they just dig more implement more grids or buy batteries, but they overlook the possibilities of flexibility. And of course, in the future, the flexibility should be everywhere, because the central power plants will be stopped. We have still a couple of power plants running due to the conflict in Ukraine and the challenges, but otherwise the plan would have been that we in Denmark, where I come from, would have closed the last central power plant. And then that this implies that the flexibility has to be everywhere in the energy system, in the homes, in the industry, and so on. And for that, we of course need this spectrum of technologies: AI, digital twins, forecasting, control, IoT, cloud edge solution, and so on. And of course, we need batteries, and batteries might become very cheap also, and then we probably need will have more batteries. But I think today the optimal solution is somewhere up here, even though a lot of DSOs and so on focus on solutions down here. Another challenge is that we need to design new markets, because you'll never be able, in my view, we'll never be able to have a market for a DSO for controlling the voltage and the temperature of transformer stations, things like that. It's simply too small, and also people will not bid into the market. So we need something completely different. But before I dig into that, I will just briefly mention that there are, if you really succeed with digitalization and demand-side flexibility, there are huge potentials in savings. And I guess we all know that, but I just think this report from DNV shows that we can save up to 80% of today's predicted investment cost and balancing cost and so on. And we have a lot of examples on these are some examples from our projects where we have demonstrated similar savings, and you can go to the homepage and look at this. So one of the things we need are, as also mentioned in previously, are digital twins. But one thing you should be aware of is that the digital twins you need are for operations. So they should be real data-driven digital twins. We don't need a full-blown digital twin, because the first digital twin, one of the examples I will come back to, is how we now operate wastewater treatment plants. And the first digital twin model we got was something like 43 nonlinear differential equations. And it took us 1.5 hours to calculate what will happen in 5 minutes. So it was definitely not useful. So, and another problem, which is even more important, we are not able to assimilate information from sensors, for instance, in the wastewater treatment plant, into the digital twin model if we have a very complicated model. So that's why we simplify the model. On the other hand, we describe all the variation, because what we are using are these gray box models, which are formulated using stochastic differential equations. Probably you don't know what it is, but that's just simplified models which describes all correlation in space and time. So another thing which is very important is to ensure spatial temporal coherency, such that, for instance, a DSO, a forecast for a DSO is coherent with what the TSO sees on a higher level and things like that. And we have developed what we call a smart energy operating system, which can build on all this level of the hierarchies and also go into the appliances and so on. So the layers are somehow like the OC layers from computers, so we can zoom in and out, and we can do that in both space and time. And this system is used to connect the edge and the cloud. And what is also important is it's connecting all the different energy vectors. So it's not only power, of course, electricity will be important. It will probably be the backbone and so on, but also hydrogen, gas, and so on will be important players. And for us, district heating is important. So what we have developed is this smart energy operating system, where in order to deal with the challenges we have with the market structure, at some point we just broadcast a real-time price, and this real-time price is designed such that it solves the problem by the TSO or the DSO or balance responsible party have. And this is the smart energy operating system is simply a hierarchy of controllers, and we are using the MIMS, the minimum metropolis mechanism, as a minimum set of standards to communicate between the different layers of the system. And of course, you're probably aware of that existing market are this merit order bidding, and this, from a mathematical viewpoint, these are static functions, and you don't really take into account the dynamics and stochasticity. This is something which becomes extremely important on the lower level, where you are on a street level or have a wastewater treatment plant and a supermarket and so on. So this translation between static and conventional market, which I still think we should have on day ahead and the high level, to the low level dynamics in the supermarket and maybe in appliances, is handled by a set of MIMS, and in particular what we call the flexibility function. So we operate very much with a lot of countries, not only in Europe, also actually in China, US. I just came back from US today, where we have some projects. But we have a lot of digitals. But of course, we have a major part of European projects. A major part of our projects are European projects or national projects. So we have a number of data platforms which are built on data spaces, and we focus very much in many projects on both mobility, and not only EVs, but mobility in general, and also the energy sector and wind and solar and so on. And we're using this MIMS plus APIs to connect the different dots, and we demonstrate this in cross-border digital platform and data space solutions. So Data Center Denmark is one example of a place where we organize these cloud edge solutions. So it's the main motivation is it's based on open source. So I very much like what we heard from Robert before. Everything here is open source, open standard, open solutions, and it emphasizes on empowering the end user and the partners such that they can provide this flexibility without being subject to disproportion to too many technical requirements, administrative requirements, procedure, agreements, and charges. So that's why we simply just broadcast the price, and then we learn the flexibility function, and many of the data stays on the edge, so they never leave the household or maybe the mobile phone. If you lose your mobile phone, you might have lost your data. But the only thing we send to the higher levels are the flexibility function. That's what the different operators in the grid, the balance responsible father, and so on needs. So these are used or described in a lot of both European projects and projects on data spaces and so on, and also international. One is from Australia and one is from Canada. Now I'll stop with some end with some case studies. One of the case studies, again, it's just high-level presentations here. The first case study is a case study where we're using summer houses with swimming pool as a battery. So we simply in Denmark we have a lot of wind, and sometimes we curtail the wind, stop the wind turbines because we have too much wind. But what we do instead here is we simply store the excess power or energy in the swimming pool, so we overheat the water a bit, and then we accelerate the ring transition in a very easy way. And at the same time, we can help the DSO providing voltage control and control of transformer temperatures and things like that. So the two areas where we are mostly running it today is these two areas of Denmark, but these are all the summer houses with swimming pools. So we developed first a digital twin model, which is just a very, very simple model of the building focusing on the swimming pool. And then we established some hardware, typically also some open source. This is a simple smart home controller and gateway where we send the data to the cloud. And Novasol, which is the commercial company who is asking for this, has a booking. Their booking, so we know when there will come new people and when the summer house is empty and things like that. And of course, we get weather forecasts, and then we calculate some optimal reference points, which we send to the edge, and which then decides what should go on in the house. So here are one example where we also are providing grid services because we are using a 5-minute resolution to optimize the operational of the grid. So here we are at this point in time, and then the prices over the next 24 hours looks like this. And then we can see that the prices are minimum here, so we should overheat the pool here, and then we can stop heating later on. So we only heat here when the prices are low. This house decided to use a CO2-based control, but because this is also a possibility that we can zoom in on optimizing or minimizing the carbon footprint. So this house here we have a forecast of the CO2 content of the electricity mix for the next 24 hours, and we can see that the CO2 content of the electricity mix is minimum in this period, and this implies again that we heat the water up a little bit more. And the limits you can see here. Here we'll get another family which requested another temperature zone or temperature interval. And of course, we have an app where we have human in the loop interface for this type of things. So with this, we can save 30% approximately of the cost or the CO2. This is a cooling house in Aarhus, actually, where we have used the cloud-edge-based solution for balancing and actually also for controlling the temperature of this transformer station. But I actually decided for time reason not to show with the transformer station, but only show how we save by doing balancing. So this is just inside the cooling house. We have a lot of sensors and develop some measurements technique and so on. By using the flexibility function, we know that we can in general avoid to buy electricity when the electricity is expensive. These are the gray areas are the spot price we have seen for a particular period. So these are real life data. But due to from the flexibility function, we can see that instead of having the green normal use of energy, we can just buy the energy when it's cheap, and then actuate do the cooling when it's cheap. So this is how we then do it, and again here we saved maybe 20 to 30%. A final case study is a solution for wastewater treatment plant, which is joint work with Veolia in France, and some systems are up and running, both in Europe and outside Europe. So again, we estimate the flexibility function because if we have a relationship between the price and the response, then which is the flexibility function, then we can also design the price we should have in order to do the balancing service or grid services and things like that. And a wastewater treatment plant is characterized by the fact that their main concern is to avoid overflow in the street, and also to maintain the active bacteria in the plant. So maybe the third priority is to save costs. So so using these concepts, we have then implemented the solutions locally and in the cloud and combined it, and the savings are between 30 and 50%. And of course, I can send you some articles. So the conclusion is that from all our experiments, and I just showed a few, we can save between 10 and 80% using this cloud edge based solution, zooming in on how to activate demand side flexibility. And we have developed this smart energy OS, which is a hierarchy, a spatial temporal hierarchy for implementing this type of solution in real time. And one thing I should probably also mention, in the beginning, you showed Energinet as one example in Denmark where we have a data hub, and that's true. But the data hub at Energinet is for electricity only. And also this data hub are historical data. But for this type of system, we need real-time data or near real-time data. So that's why we are using this non-profit organization, Center Denmark, which now is a European non-profit organization for doing that. And in order to activate things on the DSO side and doing it fast, we're using control theory. And that's a way where we can describe the dynamics and take stochasticity into account. And we use the flexibility function as one of the essential MIMs to characterize and activate flexibility simply by broadcasting dynamic price signals. So these are very, very simple standards. When we try to do sector coupling and so on using these IEC standards, so we tend to fail. We cannot make it work. Of course, when we stay in electricity, we can make it work, but the MIMs make it possible to operate across different platforms. And the system has a built-in TSO, DSO, balance responsible coordination. So that's it. Thanks a lot.
Thank you very much, Henrik. Sorry, Natalie and other people in the chat. Somehow it didn't load properly for me and I missed questions earlier. Maybe, I don't know, is there a quick question now for Henrik? Otherwise, I would propose that we continue with Blaine and then try to use some extra 10 minutes for the general questions and discussions. Thank you, Henrik, very much.
Thank you, Hannah, Henrik, and all the other speakers. It's happy to go last because I get to see all the great stuff you talked about, and I won't repeat too much of it, hopefully, as we go through here. Let us move in. Minimize the screen here a little bit. Just build that out. So my name is Blaine Matthew. I'm CEO of Protexo. We're a private company focused on helping to deploy edge-to-cloud solutions, primarily in the energy space. I am a Canadian based in California. The company was founded by 3 Norwegians, and our main development office is in Malmö, Sweden, actually. So we're sort of spread around Europe, Northern Europe, and into the US. And the core platform that we provide, Gartner describes as an edge management and orchestration platform, or edge to cloud, as opposed to cloud out to edge management and orchestration platform. And the way to think about that is the ability to rapidly design, simulate, and ultimately deploy and manage complex applications that need to at least partially run on the far edge, and in some cases, totally. Let's continue to dive in here. So you guys understand the value prop of edge computing generally, especially in the industry case. as Gartner describes, the four Ds of the energy transition are happening right now at a rapid pace, right? Decarbonization, decentralization, democratization, data being created and consumed by many more different parties than before. And finally, all enabled by what we've been talking about for the last hour and a half is the digitalization of this. And again, I think if you're on this call, we already understand why edge computing needs to be a critical part of enabling these systems across this distributed, decentralized edge for latency, cost reasons, especially, one thing that we hear more and more often is system resiliency. So they've done, I read recently about a test they did in Texas here, actually, at ERCOT, one of the largest grid operators in the US. And they tested what would happen if they took the communication system down in a power outage, and of course, not too much went well. So there's a lot of elements to system resiliency and being able to keep things running at the grid edge or at the energy edge, even if your communication to higher level clouds or servers goes down. That's a critical element of resiliency. And in fact, I am right now in Orlando at Distributech. So Distributech is the US's largest grid and electrification event. It's a massive event, and I was speaking about some of these things I'm talking to you about right now, actually yesterday. It's just to show how big it is, humongous show floor. As you can see, the four horsemen of the apocalypse, Hitachi, Siemens, ABB, and GE are in the center, and then everybody stretches out from there. So literally, I think 2 words are on everybody's minds right now, and in virtually every booth, and the words are edge and artificial intelligence. No surprise. Those are the 2 things that people care about and are talking about at this event, and we're actually talking about both of them right now. So the core Patexo platform enables the deployment of software architectures, solutions to the far edge. Edge nodes might be an industrial PC running in a remote transformer station or a compact substation. Also enables the design and deployment of what we call micro clouds. So Kubernetes-based clusters of compute resource that might be running on a little server rack sitting on premise to keep your data local, or it might actually be formed by combining the compute resource of a bunch of edge nodes together to create a more resilient, reliable, elastic, almost cloud-like capability to host and run software, but have that software, that solution, running, again, private, secure, on the edge. Yeah, here you go, just to give you a quick sense of what this looks like. So this person is actually building an architecture that is already running today in the Norwegian power grid for condition monitoring and analytics, and we'll talk a little bit more about that later. But I know open source is one of the themes here, and I'm sure most of you can recognize many of the open source components that are being dragged out of the large database of open source components on the left. And then the architect is assembling an application, in this case for predictive maintenance at a remote transformer installation, which is not only taking some of the telemetry locally off the transformer, which was not being sent up to a central cloud before, just too much data. But once this system has been deployed to these nodes that are running in these transformers, you can then start to layer on interesting new applications. For example, you can see there's a microphone here, and although most of these components are open source, there are some proprietary algorithms that were created in this case, an audio wave analyzer that can actually listen for the sound of partial discharge coming off the transformers using the microphone that's plugged into the edge node. So once you get the basic capability to compute at the edge deployed, you have a capability to manage, then you can just start adding on additional use cases and applications over time as you see fit. It can become quite interesting. Tell you a little bit about how we think about architecting the world. So there's obviously the device and hardware layers, OS, and Patexo is basically agnostic to all of this. We run primarily on Linux-based implementations. And then we talk about the edge a lot, but of course there's usually a place for central cloud somewhere in this stack. It might be an on-premise, an OpenStack cloud running on-prem, or it could be one of the major hyperscaler clouds as well. Maybe that's where your ERP system is running, or your field service ticket support system. That's perfectly fine. The stuff in the middle, though, is the stuff that needs to run and be managed on the edge, using in our case using the edge management and orchestration platform that I showed you briefly a second ago. And one thing, and this is, I think, so the connection point to some of the other presentations we've seen so far. What we found is, these are early days for the use of edge computing in energy and industrial systems. And so we can help accelerate things if we can give people a little bit of a kickstart closer toward actually getting a completed solution done. So we've created these things we call solution frameworks, which are pre-built, still highly customizable, call them 80% complete solutions that are addressing different areas or use cases in the electrification market today. And they're available to help accelerate folks and to finish customizing and completing. But of course, you don't have to use a solution framework. You can create something from scratch quite quickly and manage the deployment of it in quite complex deployments using Protexo. Just to dive maybe one click deeper into that. So the core technology I mentioned, using Kubernetes for application or system containerization, but we can also deploy natively in cases where maybe the hardware is not able to support some form of Kubernetes. Our platform itself is built on top of a large stack of open source components, and as I mentioned before, what we allow an architect or a solution developer to integrate and then deploy is by default a fairly large set of open source components. But of course, you can also add your own proprietary systems, your analytics, your Python scripts, whatever the case is, into the platform as well. So you can also manage the deployment of that. The studio is actually the UI I showed you to make that happen, and it includes different ways for designing the core architecture, enabling really the notion of a digital twin of a device. So we do that so that you can begin doing simulation and testing of these applications and architectures before you do a single physical deployment of anything. That dramatically speeds up and de-risks any of these deployments. And then finally, I mentioned the solution frameworks that a few minutes ago, and now we have these solution frameworks in different stages of production with a number of different companies. We do a lot of work with ABB. ABB actually invested in Protexo last year in 2023, and we're becoming a really core part of the software stack that they're now wrapping around some of their electrification hardware, in particular, switchgear and various things to make sure that they can increase the uptime and efficiency of their machines and offer that really as a service to their customers. I did mention this one briefly before. So HKN, Hallingdal Kraftnät, is running Protexo software as an example in the Norwegian power grid today. They've got many hundreds of these remote transformer stations. You can see on the right the DIN rail with the panel. By Norwegian law, you have the transformers themselves are putting off data, but they have to have backup sensors as well, collecting the same data, so they always know what's going on with these things. And but unfortunately, especially due to low levels of connectivity and just too much data, they weren't really doing much with this until they began to implement the ability to do first level processing and analytics right on site, like I was describing before. And now we're beginning to layer on the other sensor types and devices like cameras for detecting people or animals near the station, microphones for listening for partial discharge, and a bunch of really interesting and innovative use cases that are being implemented right now and all deployed locally. Oh yeah, just to give you an idea of what this sort of architecture would look like conceptually. So each transformer station is running a set of devices and sensors locally. These may be connected by different strengths of connectivity, you might say. Some of them have high-speed fiber connections. Many of them have less than that. we are just now implementing through a partnership with Telenor in Norway, beginning to connect more and more of these compact stations with 5G as Telenor is rolling out 5G across more rural areas. That's an important partnership for us, and I think it's going to really allow grid operations in Norway to achieve a much higher level of visibility based on data, and that's all in the process. And then, as I mentioned at the top, this notion of in certain cases, especially where there's a higher speed capability for connectivity, we're taking groups of these individual compute nodes running at these transformer stations and grouping them into what we call a microcloud, which gives us the ability, or gives them the ability, to run high performance, more resilient, scalable applications, not just in each individual station, but across a set of stations. And our software manages the deployment of all of that. Let's keep rolling here. Oh yeah, right. And my talk that you saw earlier today was actually on energy system resiliency. That's the overall theme, I guess, of Distributech this year. And obviously, really, it's an important area that everybody's thinking about. We did just release a couple of days ago at the event our new generative AI-enabled system. Fundamentally, what it does is, if you would like to spin up a system for really understanding the root causes of complex machine failures and then be able to predict those failures in advance, building such a system could take a considerable amount of effort, right? And we had the idea, after we initially developed the framework for a root cause analysis system with ABB over the last year or so, to really use generative AI and take that to a whole nother level in terms of the ability to deploy, to design and then deploy using Protexo system exactly like this. Let me give you one quick minute, because I think it's relevant and interesting. And this is using an open source large language model to make it happen. So the idea is a machine expert, somebody who understands, let's say, a power transformer, and that's what we're talking about, is going to use this system to create basically a fault cause graph of all the potential faults that could happen with that machine or that machine type, and then predict the performance of that machine, have the Gen AI automatically write the prediction algorithms in Python, and then take actions using it, and have all of the system deployed using the edge management and orchestration platform I showed you briefly a couple seconds ago. I'll just show you one thing quickly here. So let's say power transformer in compact substation. And we could type any machine type, any industrial machine. It doesn't matter. We can provide the AI with more context about the equipment or machinery if we like, but I'm not going to do that right now. So what I'm going to do is use the AI to generate an initial fault cause graph. And this is basically forming the skeleton or foundation for a predictive maintenance application that understands what faults it will identify, what could the causes be, what would the indicators or algorithms be necessary to identify those faults and causes, and then what sensors would we have to have in place. And I'm not going to take you through it now because it would take me an hour to do a full build out of a complete running system. But to show you what one would look like when you were done, this is the one I created yesterday for the demo I did. And what it actually created in about an hour was an actual running application that could be deployed to the edge that will detect overheating and oil leaks using a range of sensors, and then fire off particular actions. Could be a message onto an MQTT stream or an SMS message or you name it. And all this is done enabled by AI to be deployed to the power grid edge in this case. Amazingly quickly. So that's what we're talking about here on grid edge resiliency AI, bringing it all together. I think this is my last slide. So that's fundamentally what we're working on at Protexo these days, and happy to take questions or go wherever you'd like. By the way, this QR code here is a link to all the materials that we're using at this particular event. We're going to be at the ONS Energy event in Norway in August, I think it is, and a number of other events across Europe over the next few months. I think that's all I got.
Great, thank you so much, Blaine. So there is a question in the chat right away, and this time I didn't miss it. See your solution frameworks, but wonder where a framework like root causes analysis would be executed. Seems like it would run in the center somewhere, not at the edge.
Well, you would have the choice of deploying it where you wanted to. It would depend probably on the level of data you had and data security that you required. But the example that I just showed you, the intention would be to actually deploy that at each compact substation, that be able to analyze the data coming off those transformers locally, and then instead of pushing all that data up to a central algorithm for processing, push the algorithm down to where the data is, and then just fire off a light event stream like an MQTT message. We predict this thing is gonna overheat in the next 24 hours, right? Or you have an oil leak. We all know that would be a great edge computing use case. So push the analytics down, and that's what we're doing here, is defining what those analytics would be, and then being able to push them down is done with the orchestration platform.
Cool, thank you. Mark, does that answer your question?
Yes, can I ask a follow-up very quickly?
Please.
You're working a lot with ABB, and ABB makes transformers, I know, or at least they used to.
Yeah,
used to. I mean, a lot of these kinds of generative AI models will depend on the subject matter expertise of the manufacturer. And yep. I'm probably one of the few people on this call that's actually knows what partial discharge acoustics sounds like in a transformer. So anyway, are they providing that subject matter expertise so that there's some validation? Because I've had situations where the maintenance department basically says, go away, leave me alone. We wait till it blows up and then we fix it.
Yeah. I think it is the OEMs like ABB, Hitachi, and et cetera, who will be the ones who primarily use the system to create the fault cause graph, and then they're going to make that available to their customers as part of their service they provide. I think that'll be the most likely scenario that we see here.
Thank you. So we have another question from Natalie. For you, one of the motivations on edge-driven solutions is energy efficiency. How much of a consideration is it for the use case described, carbon footprint?
Yeah, great question. So, that's actually the sort of the core focus of Protexo. Our mission is to enable the energy transition. Our vision is to help accelerate our ability to hit some of the carbon reduction goals that we're not doing a great job of hitting right now. But our lead investors in the company are actually all ESG oriented venture capital companies and others. So we are very focused on, I talked a lot about efficiency and machine downtime, but the ultimate reason you want these machines to run efficiently and to spin up these next generation solutions in months, not years, is because we need to do that, right, to hit our goals. And so that's the fundamental premise. So when I talk about machine efficiency or uptime or root cause analysis, there's a bigger picture thing we're all trying to achieve, and I think we're not going to get there if we have the mindset that especially the energy industry used to have and still has in large part, is built to last, launch it, and then leave it for 20 years, right? And like my former Gartner colleagues say, the mindset has to shift to, instead of built to last, that has built for change. That's what we have to do. It still has to work, don't get me wrong, but it has to be able to change and evolve rapidly. So anyway, that's what we're focused on helping.
Great, thank you. So I still have a lot of questions for the other speakers as well that I didn't pick up on earlier. We'll see what more we collect in the chat. Thank you so much, Blaine, for that overview of Protexto. That was great. And I mean, I would ask Henrik, maybe as a first, there was a question to you, SEOs, SEOS, does the operating system run models as applications, and are there application shops? You're muted.
Oh, sorry. Yeah. The Smart Energy operating system is a framework, and we have different libraries. So like on computers, you can have different implementations of things. But there are common denominators, and where we develop the open source tools which can be downloaded. For instance, these data-driven digital twins, which are extremely important. We have libraries for the flexibility function, which is what connects conventional market theory with the dynamics on the devices. So this is something which can be downloaded, and it in the actual implementation, it of course the flexibility function runs on different levels. For instance, and the same do the digital twin. Digital twins are typically used on the end user level for advanced control and things like that.
Yeah, makes sense. Thank you, Henrik. Then there's still lots of open questions for Robert. The first one is from Natalie. How do you envision ideal, based on your architecture vision, demand response services enablement orchestrations?
So ideally, I think that goes via the CPO. So the charge point operators should talk to the TSOs or the DSOs to get input that they need, and that can be either something like OpenADR or IEC 61850, which does a lot to control devices on the grid. And then they can send that via OSP. OSP supports smart charging already, and bidirectional is being implemented at the moment. Mm-hmm. So at the end of this year, that also should be possible. We're waiting for vehicles. Mm-hmm. That's the main. And for home use, an energy management system at home or in an office building on a fleet location, local energy management system, talking to some DER function.
Then there's another technical question from Kees van der Klauw. Is there a data layer that is specifically focusing on micropayments and dynamic tariffing related to automated charging?
Specific data layer? Not really. OSPP provides functionality to provide enough data for doing payments. And dynamic pricing, there are already solutions where charging stations are receiving dynamic pricing and are taking that into account to do smart charging.
But it's not super specific to your
we are working with, at least we are working currently with one provider of, they have an integration platform that provides dynamic pricing for like half of the energy companies in Europe already. And we've tried to set up an integration with their platform. So if somebody wants to build charge with Everest, they can easily add that platform to get dynamic pricing into the charger.
Okay, cool. And then from Wilbert, what's the key trick to keep the lively open source community going with multiple contributors? Community question.
Be nice to each other. That's one, I think. No, I think we are at a interesting point in time at the moment. We are growing that quickly that we are, almost, I would have to say we have to do something, really change some stuff. So one thing we did now is have multiple working groups, so at least people can focus on stuff and don't have to be in meetings where half of the things are not interesting for them. What we are currently struggling with is we get a lot of contributions from the industry, and we have to keep up with their requests to get that stuff in and keep the quality to the level it needs to be. But we try to be as open as possible with the community and have as much meetings so we really get to know each other, which is really nice. Which was for us as well. We have, as we said, the test event here. I think half of the community working on Everest is here. It's nice to have a drink
so
after an event like this.
Yeah. You can touch and
helps.
feel and smell and that's good.
Helps to build the bonds that you need in the end to do huge projects, definitely.
Yeah, great. And then we have a question for Wilbert from Natalie. If Wilbert's still on the call, not hearing or seeing him currently. Sorry for that, Natalie. Missed him. However, there is another question that's going in line with for Blaine, I think. Continuing this line of thought, is the orchestration fully static, or is there any kind of dynamic orchestration where the location is not chosen, but the best fit for it among the available infrastructure is automatically chosen instead of being given by the end user?
Great question. Absolutely. And we see that scenario a lot where they may be, for example, in the Norwegian grid, we may be starting with a low speed connection, but then they get upgraded to a high speed connection. The system can be set to automatically adapt to that. And for example, in a low speed connection, the edge node might not be part of the Kubernetes cluster because you can't run Kubernetes over that speed. But when the high-speed connection is enabled, the system senses that, I can make this node part of my cluster and will automatically push out the additional software required. So really, great question. I think we're going to see more of that dynamic capability required over time.
Great. So I would say if there's not a very urgent question, please just raise your voice. Otherwise, I would like to thank all the speakers very much for all their interesting input and also the great questions we had, and then give us a well-deserved coffee break for 5 minutes. But I see Dieter Jung coming up. You still have a question?
No, I just joined actually for the next session.
Okay. Okay, so I would say coffee break it is then. See you back in 5 minutes.
Yes, see you all in 5 minutes for the next session. Hello, everyone. Just giving everybody a couple more minutes to come back from the break. I hope all the use cases are here. Hello. Hi, Keith. Okay. Okay, so I think a couple of minutes past the established time. I think we can start. I hope you can all see my screen now. Oh. So this session is the use case pitches from the MetaOS portfolio. My name is José Luis Lorenzana from BlueSpecs. So a little bit about BlueSpecs. This is our 10-year anniversary. We are helping organizations with tech adoption strategies. And in these 10 years, we've developed an ecosystem of partners that counts over 500 corporations, be it large-scale companies, startups, SMEs, etc. And in over our 10 years, we have helped unlock over 18 million euros in investment in tech. So yes, that's a little bit about BlueSpecs. Now I will share the goal of the session. So the goal of the session, as it is with our participation in this project, is to link frontier tech use cases to industry needs by identifying the path to integration into existing energy operator processes. So for that purpose, we will have a session where where the 6 pitches from MetaOS use cases related to energy will be presented, and we have also set up a jury team over which members I'll go over shortly. And the 6 use cases are related to energy management and decision support system from ICOS, intelligent power grid from Fluidos, edge computing containers near renewable energy sources from Aeros, and energy management in smart building of cities from Nefele. Then we also have energy and utilities, windmill maintenance from Nebulous, and last but not least, smart energy and smart mobility from the NEMO project. So having said that, from the jury panel side, we have Kristin Asmussen from EnergyNet, Klaus Beetz, who's a consultant and former CEO of the EIT Manufacturing. We have Vasilis Iliadis from AES Technologies, Kees van der Klauw from InnoAds and the Dutch AI, and is also the Dutch AI Coalition leader, if I understood Dutch correctly. We have Dieter Young from Rialto Energy, and Francois Fischer from FSCom, and last but not least, Mitja Antonczyk from LS. So I hope this session is useful and interesting for you all. So again, from my side, last thing, thank you all again. Get in touch if you'd like to try the pre-release of the Ceiling tool, which is a tool that we are developing, and the Unlock project to test the suitability of solutions to be brought into your corporations. We can also help you develop your corporate venture building, and of course introduce novel solutions into your processes. So for any questions, you can also reach out to me later at my email, as you can see on the screen. So having said that, we can start with the use case presentations. there was a particular order, but I don't see Nacho on the call yet, so maybe we jump to the next one. Elisa, if you don't mind starting. Thank you.
Yes, hello to everyone. I share the screen.
Yes, we can see. Perfect.
Thank you. Hi, I'm Elisa Albanese. I work as a researcher for Ricerca sul Sistema Energetico. And today I will present you the energy use case of the FluidOS project, which is intelligent power grid. Our focus is to enhance distribution grid monitoring and control with the use of phasor measurement units, which are measuring devices that gathers electrical quantities from the grid. We then have phasor data concentrator, which collect data from the phasor measurement unit. And we have application monitoring and control application based on the grid state estimation algorithm. The phasor measurement units have a reporting rate of about 50 frames per second, and they are synchronized with GPS. This reporting rate is significantly higher with respect to traditional remote terminal units. So that's why TSO have deployed this kind of system to have an unprecedented observability of the power grid. Our main goal is to use this synchrophasor measurement system also in the distribution grid. But the introduction of phasor measurement unit into the distribution grid brings various challenges. First of all, scalability. The number of PMUs required for the distribution grid is significantly higher, from 100 of the transmission grid to thousands. Data streams cannot be handled with the centralized bare metal monolithic workloads, but we need virtualization and orchestration techniques. The second major concern is resilience. With thousands of devices in play, enhancing the resilience of the entire ICT infrastructure is crucial. And to do so, we need to automatically handle failure. The third major concern is latency. Real-time control algorithms need have strict data latency requirement, about milliseconds. And then another main problem is cybersecurity, because as you may know, the massive introduction of ICT technologies exposes the system to new threats and vulnerabilities. FluidOS, which is the European project in which we are involved, offers a flexible, scalable, secure, and decentralized operating system, which creates a computing continuum. A computing continuum is a virtual space spanning across multiple technological domains, from the edge to the cloud, but also across multiple administrative domains. FluidOS technically is based on vanilla Kubernetes and Lico technologies, so is about orchestration. The computing continuum of FluidOS would enable, in our case, phasor data concentrators application and grid state estimation to continue functioning by migrating these services to other nodes, for example. In this case, we see that we have a grid state estimation algorithm on the top in the private cloud. We have a disruption of the connection, and the grid state estimation is then shifted automatically locally at the edge. The second main feature of FluidOS is the intent-based orchestration. FluidOS can automatically orchestrate PTCs based on different intents. That could be location, battery level of a certain device, or in our case, latency. So we can orchestrate services based on the latency, for example, between the PMUs and the PDC, or between PDC and applications. And that's really useful to improve the power grid state estimation and to respond to faults. Last, service isolation and anomaly detection. Fluidos ensures advanced anomaly detection capabilities as based on federated learning and also isolation of the services from other applications and from the hosting nodes. What are the FluidOS advantages for the intelligent power grid use case? So through the computing continuum, FluidOS is able to effectively manage a number of PMUs that is about 1,000 as we need. Then from a resilience point of view, FluidOS automatically responds to faults, forced disconnections or node failure, and also allows to do maintenance without causing electrical downtime. And there will be no need for specific hardware redundancy. Then FluidOS improves also application performance by satisfying the application latency and availability requirements through the intent-based orchestration. And it also enhances the security measure of the entire ecosystem and simplifies the maintenance with the reduction of software update time on distributed devices, and also with the reduction, for example, of failure data loss in case of grid reconfiguration. The primary activities of our use case are in the low voltage portion of the RSC distributed energy resources test facility, in which we have loads, PV panels, charging station, storage system, and so on. We also leverage edge resources like small Raspberry Pi or industrial computers, and we have also a private cloud infrastructure, which is based on OpenStack. So I thank you for the attention, and I'm here if there are any questions.
Great, thank you very much. Any questions for Elisa? Yes, please.
I have a question on the federated learning. So how is that arranged? Is it federated learning by the individual nodes, or is it federated learning in a centralized system and then deployment of the result? How do you do that? Okay.
Yes, federated learning is used for anomaly detection capabilities, and it is deployed on the FluidOS node, which we can say it is a single Kubernetes cluster. So on a single Kubernetes cluster, you are training a model with the data of the single Kubernetes cluster, and then you match this model with other models of the FluidOS ecosystem. So you are doing it's a very interesting topic because it regards also data privacy, which was mentioned before, and certainly it is a good point of research.
Yeah, and there are some, let's say, you could say you have a better resilient system by having these distributed edge computing, but on the other end, the centralized software updates from the federated learning poses an additional risk if you don't do that well.
Yeah, exactly. But it's for anomaly detection capabilities. So first of all, we are training the model with an entire data set. We can say a centralized model is then the first detection is made with a centralized model, but then you can update the model with the single federated small models of the whole FluidOS environment. That's interesting because you have updates, and FluidOS is not only on the energy use case. It's about different use case. We have a robot use case. We have a smart agriculture use case, and so in different domains you have different threats, completely different threats, and so it's very interesting to train models on the single nodes.
Yeah.
Thank you for the questions. I think, Jose, you're muted.
I am muted. So Klaus, please go ahead.
Okay, yeah, thanks for the interesting presentation, Elisa. I like very much your last answer you gave to Kees, my good old friend. Hello, Kees.
Hey.
Nice to meet you. About that you also had a look in other domains because there are similar problems in other domains, and there are similar solutions around. And this is my question: how you really differentiate to other solutions that deal with the issue to balance between the central, the cloud, and the edge, what to do where, and how to manage the distribution.
Yes, Fluidos is a computing continuum, so we are not moving data. A lot of solutions are focusing on deploying applications on the edge and then moving data to the cloud. We are not doing that. We are moving workloads. We are moving application. So it is very interesting from this kind. This is what really differentiates Fluidos from other solutions. And certainly, one additional thing is that we are a solution that is addressing different problems with very high expertise on different fields. So we are tackling security with a zero trust paradigm. We are tackling challenges about scalability, which is nowadays a big problem, and also resiliency. So I think that working on orchestration and inter-person orchestration is something that certainly differentiates us from other solutions.
Great, thank you.
I don't know if I answered.
Seems okay. We have time for maybe 2 more questions from Mitya and Dita, and then we have to move on, unfortunately. Thanks for the questions, very interesting.
Thank you. I would have one question related to the use case itself, so to the primary idea. Where is the motivation for using PMUs in also distribution network for state estimation? So maybe it's not really related to the platform itself, but the source of data that you are working with.
Yes, PMUs respect to, as I said in the presentation, respect to traditional remote terminal units and SCADA system have a high reporting rate and GPS synchronization. That's true that also we can use other meters that also have GPS maybe. So the theme maybe is more broad. So it's about synchronized measurements, synchronized meters, but certainly PMUs are useful for our application, which is grid state estimation. So using PMUs, which gathers voltage, current with amplitude and phase, gives us a linear resolution of the grid state estimation, which also has a mode, how can I say, a computational time that is very lower because it's a linear problem. So from this kind of certainly from this kind of point of view, it is very useful and efficient to use PMUs also on the distribution grid. I don't know if I answered.
Thank you.
Okay, great. Thank you. So one last question from Dita, and then we have to move on. Thank you.
Yeah, I think you emphasized, thank you for your presentation, by the way, but you emphasized quite a lot on the high frequency of data load that you could gather to the grid state estimation. I was just wondering, in terms of commercial application, do you need for which use cases would you need that high data load? And is it also possible to scale down, for instance, to a lower data load in order to enable more use cases, so to speak?
Yes, in the presentation, I didn't mention that Phasor data concentrator, which are the devices, the services that virtualized services that collects the data, also make aggregation. So it's not only to deliver the data on the cloud or on other application, but it's also to aggregate it and to make the data stream useful for the application that you have. So that's very important. So the hierarchy of PDC at the edge, at the control center level, at the DSO, at the substation level, is also the function is also to store what you need and also to deliver to the higher level what you effectively need for the application. So that's why also we need a hierarchy of services.
Okay, great.
I don't know
Thank
if
you.
it was an answer. Okay.
Great. Thank you for the presentation. Then we move on to the next use case, which is we will be presented by Prasanth. Now I see that you are in from IROS. The case is edge computing containers near renewable energy sources. Prasanth, can you share your screen?
From IROS, it's Martin Michel.
Ah, really? Okay, sorry.
Yeah.
I had the wrong name down. Sorry. Martin, please.
Yes, sharing the screen now. So what we have here is the case for green compute on the edge. The problem that we're trying to resolve is the high energy consumption of
sorry,
much.
I can't see your screen. It's white.
No. Yep.
Maybe, I'm not sure it's only my computer, but
no, I can't see it either.
Okay.
No, we cannot see it. Yes.
Okay, my screen, huh? You still can't see my screen?
No, we do not see anything.
I could share the screen, but if you could tell me this is the presentation that you sent to Nacho.
Hold on, what's wrong with this one? Once again. Can you see it now?
No.
No.
Maybe I'm not authorized to share the screen or something on this.
I think you should be. Let me quickly. You are allowed.
Are you working on multiple screens? You may have to drag it.
That may be the case.
Do you want me to share it?
Sure, go ahead.
Okay.
I don't know. I'm sharing. No error is popping up. So.
Okay, one sec.
Well, basically what we are doing here is the meta operating system, and in our case, in case of Electron, we are delivering a microservice for this meta operating system that providing the opportunity or functionality to orchestrate the compute load. So first we can transfer the load of some operations in case of energy sector. Some operations doesn't have to be handled by the data center servers. It's more efficient that they could be this compute operations could be handled locally on the edge. You can go ahead and put it on the full screen, and the next slide maybe. Yeah, there's also a problem with the bandwidth. When you like, to give you a picture, when we have a virtual power plant system and a SCADA system, and there is a local video analytics for clouds for last minute prediction or correction of the prediction for our yield prediction algorithms. Then we have a lot of video data that in most of the time is not useful, because this clouds are constant, nothing is changing. But there are some times where the local inference is generating a lot of data, and we don't have to transfer this data to the server. We can locally process this data. But also there's a business case for distributed data centers. And we partner up with Cloudflare for this project to test the case. What is the business?
Sorry for interrupting. I don't see the slides. The other colleagues?
Now I can see them.
I can see them also, yes.
Now should be okay, yes.
Yeah.
Yes. So these are the I don't know what's wrong. I can see this slide, so
yes, we can see the slides.
Screen.
Yeah.
Yes, so we came up with the solution. Solution is based on the microservice that is using machine learning, constant machine learning operation to predict the price of the energy in the next time window. So the orchestrator of the system can be configured in the way to to transfer the load from one location, one container full of servers, let's say, to the other one, depending on the weather patterns and prediction, whether it's going to be a windy day, shifting this, green energy share in data center, in high performance computing operations towards the energy farm versus the PV farm when there's a sunny day and no wind. So this is kind of a challenge here is to achieve very fast response and a very good planning ahead, because some of this distributed compute nodes, they are using big chunk of data, and it doesn't make any economical sense to transfer this big chunks of data between these distributed locations. So this orchestrator has a lot of parameters or algorithms that the goal is to have an autonomous operation that would distribute the compute load in the most optimized way, and it's quite complex system, but the case is quite big. The growing interest of AI applications and this growing power consumption is quite a big problem, and we believe that it's quite different. Traditional data centers versus this GPU accelerated AI factories. The business models to operate them are quite different, and there's a case that this distributed small container-based clusters that are using surplus green energy, or could be managed to use a big share of green energy in the process. We believe this is something that that will have a very high interest on the market. So yes, and then during this process we have in this just pilot program we have the several key performance indicators to check and prove that to check the case if the systems could be functional, and without what would be the limits, right? Because some of the remote locations like power plants, they have cheaper energy available, and sometimes some surplus energy because you have grid connection limitations and high yields in short time windows. So this is kind of systems and energy storage management, but imagine that you can store energy in form of computing power, right? When the cluster is very widely distributed, it's getting big, and the systems could be orchestrated. They don't need to be like the deep learning models. They don't have to be permanently in training. The training could be scheduled. Then we could possibly have a platform that has a very low OPEX, and it's secure, and it's very easily scalable. And for that reasons, we are using like distributed SQL solutions and trying to build this architecture in a very I would say stable, solid way. This is the diagram that shows the implementation on this pilot too. We have the existing SCADA and existing system where all the telemetry and data aggregation is being done on the local edge computer. There are also runtimes for, like we use this NVIDIA Triton inference server for local data inference, and Areos runtimes on the same chip system on a module, and then we have a possible battery system and this compute container full of different servers with different infrastructure as a service options, and this is provided by Cloudflare for this pilot. And this is just a high-level view on the architecture, how these clusters compute nodes are organized. Yes, but this is generally speaking meta operating system with a microservice that provides future energy price information and availability per location. And we believe this is just this pure microservice could be interesting solution for some partners, and it's going to be an open source solution available for everybody. Thank you very much. Any questions?
Great, thank you very much, Martin. Sorry for the mix-up earlier. Any questions for Martin? Yes, Keith, go ahead.
Yeah, on the so I understand that you can distribute the workload according to the projected energy availability and prices, but how about the other side? Because you're providing this service to people that do want to have heavy load computing. So how would you interface to that side?
Well, in many cases, how to give you a picture? Like, okay, maybe this is a good example. Maybe Bitcoin is not very popular anymore. However, cryptocurrency, I believe it's a good concept, mathematically speaking, at least. So a proof of work using asymmetric cryptography is something that makes sense for some applications, right? And especially if I can have a clear certificate that my proof of work on this crypto is totally green. There's no carbon footprint in this crypto. And with this, I can orchestrate this process to make this economical sense with this solution that we are developing. Maybe not a good example.
No, so my guess is that you
finance systems,
Yeah. So my guess is that you would have, let's say, many users that want to have their computation job done. So you would need a kind of automated, let's say, market interface where you connect the availability of power and computing power with the loose or strict computing demands from your customers, and that front side, of course, those are your customers, I think.
Yeah, I mean, I understand your point. This is when you invest in some hardware infrastructure, you want to have it load 100% of time, right? That's but also if you think about virtual power plant solution that is virtually transferring available energy from one source system to another, maybe there is a possibility that you can orchestrate your majority of your load, let's say, right? Majority of your load you could orchestrate by the cheapest energy price or only green energy price, share, right? You could do this. So we believe that that there is a business case for that, on the market. I think there would be systems getting more and more popular when people will not use it unless it is green.
Yeah.
I'm not using this AI. It's nice, but I'm not using it because it has a set,
Thank you.
Great, thank you. I think, Arthur, maybe a question, maybe a support comment. I don't know.
Support comment from me, because I'm the Cloudflare representative here. And what I could say is that we are at the beginning of this way. So the big obstacle for us, for instance, is the connection, because as Martin said, usually the photovoltaic farm or other things that produce the green energy are in the middle of nowhere, and the internet connection either exists or not, or is very weak. It's not like you showed us in previous presentation that you try to implement the 5G technology. So for us, I have to point out that we are at the beginning of this path. This is the big obstacle for the heavy load, as the kids ask us how we deal with that. At the beginning, we will try to do some tests, as Martin presented during the pilot 2 in the AROS project, and find out what could be improved and other findings when we're going to achieve during that pilot 2 deployment.
Okay. Thank you.
Henrik?
Yeah, thank you for an interesting presentation. I think the challenges are also the pricing, how to form the prices, because you predict the prices, but what we do in our smart energy operating system is we have a hierarchy of optimization problem or control problem, which design the prices so they are high enough to solve the critical grid problem or balancing problems, but not higher. So maybe their process could be combined, maybe more a comment or something, but.
Yes, actually, this price prediction model is based of another subject of another project, but we plan actually to organize a hackathon to find an even better algorithm, even better model, even maybe some improvements to the pipeline. But we are finding very good correlations between especially between this system power plants that are running 24/7 and the renewables that are running like crazy. So we find this big correlations. You see the export and import volumes between energy markets, right? And the price. It's of course a casino game, right?
Yeah.
Kind of, but we would like to create a high precision reference price for your other applications, right? When you can have this the clear, transparent analysis, and you can use your Tableau or Microsoft, business intelligence, whatever tools to play with this data, but
but we probably also need the proper dynamic tariffs and so on. So, but we can discuss that bilaterally also. Thanks a lot again.
Thank you very much. Yes, we have to get a move on a little bit. Also, just to remind everybody, there's a Q&A functionality in the meeting. Please feel free also to put any additional questions in there. So next, I hope I don't get it wrong this time. The project ICOS will present Energy Management and Decision Support System, or EMDS. That will be Rosalia Davi. Please go ahead. Thank you.
Sorry, can you hear me?
Yes, and we can
I've
also see your screen.
shared my screen as well. Hi everyone, my name is Rosie Davi and I work for SEC Electricity. We are part of the ICOS project together with several other organizations around Europe. The aim of the ICOS project is to build a meta operating system that leverages IoT, edge, and cloud capabilities. Specifically, what we bring to the project is we participate as use case leader. This is one out of 4 other use cases in ICOS. As Fluidos was presenting, these are very different for use cases, and this particular one I'm involved into is related to energy and specifically to try to optimize energy usage in a domestic setting. Using artificial intelligence and machine learning models. At the moment, it's more of a proof of concept, and we will be using 5 houses, which are equipped with very smart technology, including smart meters, a solar panel, heat pumps, electric vehicles, and so on. So the idea is to use the ICOS capability of orchestrating the workload inside the application, and especially the ICOS AI brain to anticipate to forecast the energy usage at a very granular level, and at the same time to understand the solar output, the EV requirement of customers in a world where everything is very dynamic. So we want to provide customer with detailed suggestion on their usage and how best they can use their energy going forward in a way to change their habits in shifting usage of energy in off-peak times. At the moment, ICOS and the use case as well are at very infancy level, let's say. So ICOS is divided into 3 phases, and we are just completed the very first phase, the alpha phase. The energy management system has been, infrastructure has been built using open sources technology, and it comprises of an IoT device, which includes the use of inductive energy clamp, which are connected to the fuse board. And they collect energy at a minutes level, so every 60 seconds energy consumption. At the moment, we are using just 1 test house as a proof of concept of the proof of concept, let's say. And we have in the test house a Kubernetes cluster of edge devices. What we want to leverage is the IoT and the edge cluster are connected with the cloud environment, which is a dedicated ICOS testbed. So it's not part of the use case infrastructure, but it's part of the infrastructure of the project. So we want to leverage ICOS capability on cloud and edge to optimize the resource and the performance of the user workloads. So particularly, we want to focus mostly on the edge to reduce data transfer and latency and increase level of data privacy and data security. And obviously, this is very important in this particular use case because we are talking about consumption data every 60 seconds. So it was mentioned many times already during the workshop. It's an indication of presence of or lack of presence of people in the houses. So it's very private data. So at the moment, we have tested the infrastructure and the calibration of the infrastructure and the integration of this infrastructure with some of the ICOS components. Again, this is all at the very early stage. The 1 test house only, and then we'll move on to installing the hardware into the other houses. And in the next couple of months, we are hoping to start using machine learning techniques provided by the ICOS AI market. This includes federated learning models for energy forecasting. And so the ICOS use case related to energy management system is very important, not only from different stakeholders, so not only from a customer point of view, because they can get good suggestions and detailed report on their usage, but it's also very important for provider like the company I work for providing a service to the customer and then increase satisfaction and retention, but also increase demand flexibility because ICOS promotes the usage of energy away from off-peaks and increase of usage of green energy, so reducing curtailments and reducing energy waste. As part of this particular use case, we wanted originally to include a bidirectional charger as part of the technology in the house. At the moment, we haven't done so because the bidirectional charger are not commercially available in Europe at the moment. So this is very early technology, but we hope that during the lifespan of the project, we'll be able to use this technology to transform this even more, use the car as a storage for the energy in the house. And so, yeah, this is the level we're at, but there is a lot of more work coming for ICOS and for this use case.
That's great. Thank you very much for your presentation. The floor is now open for questions from anybody. So just some good reactions. I think you explained everything very well. Maybe Dieter, you have a question?
Yeah, just have to unmute. Yeah, you're working mostly on residential demand side flexibility.
Yeah.
We do see is that and you're gathering, I think, minutely data you said before.
Yeah.
So I was wondering, what use cases are you focusing on mostly to deploy the technology in? Because you've listed a couple here, but for instance, bidirectional charging is like you just said, it's very, very immature yet for the moment.
Yeah.
But I do think your technology can work as well for just regular V1G charging, no?
Yes, exactly. Yeah. So this particular use case, energy related in ICOS, focus on the energy usage in domestic settings. So we have a lot of plans for the future. So we have plans for bidirectional charger. We want to have very high granularity of data because we want to start thinking ahead of feeding information back to the DSO, the TSO for grid stability as well, for frequency stability, and obviously trying to push up the demand flexibility. You're totally right. This is very, how can I say, it's very early stage for us as use case and for ICOS as a meta operating system. But I think the intentions are there, and they are very good intention also because this is how we see things moving. So it's in a way a pioneering way for a company like mine to be in the right place at the right time with the right technology as well. Very ambitious, I know.
Great. Thank you for the explanation. We have Mitya, I think, first, and then Keith again. Last two questions quickly. Yeah.
Very good presentation. So my question is similar as Dieter was. Basically, what were you controlling, or are you controlling with this use case?
Yeah.
Yeah, okay. With the clamps, you're reading the data.
So at the moment, so we are recording consumption data in general in the house. Like I'm talking about the data connected to the smart meter. So we are seeing variation at every 60 seconds. The very main, the first output we want to get from this is to try to give back some good suggestions to customers. So something like, if I can give let's say a simple example, charge your car at this particular time of night because in this particular time it will be cheaper for you. So the customer will see a cost return, obviously, and at the same time, automatically this will connect with also sustainability, because we're trying to move people away from that 5 to 7 peak time of energy usage. Obviously, the fact that some of these houses have solar panel as well, we will try to monitor exportation as well, not just consumption. So what is given back from the grid. Again, at the moment, the focus will be mostly on customer needs. So the immediate output will be how people can maximize the cost return and at the same time their exportation or usage in a way if they don't want to give the energy back to the grid, but if they want to use their energy themselves. So it's customer based as a first step, but we are already thinking about, let's say, if I can say this, an IQOS 2.0, and where the energy use case will progress even more.
Okay, so at this stage you're basically collecting data, but you plan to use it also in a kind of, let's say, home energy management system manner.
Exactly. Yeah.
Do you plan to? So,
Sorry,
in what way?
We have to be quick.
Yeah, okay. I'll be quick. Just one quick question,
yeah,
if I may. So, how do you plan to interact with the, let's say, household devices? That's one very quick question.
Sorry, I didn't hear you. How do I plan to?
Interact with the devices, so in terms of demand flexibility, so demand response. Is your system going to be connected to the devices to shut them on or off, or is it going to be done by the users manually?
At the moment, they are not connected, so there's not automatic switch on and off. So the idea would be to feed this information back to the customer. And at the same time, we obviously hope that the customer will follow the suggestions. But we also need to take into account their needs. So again, to go back to the example of the EV, so we can suggest to charge the EV in a specific time of the day, but we are hoping, like, we cannot force people to, let's say, get up at 2 in the morning to charge their car if they don't want to do that. Yeah.
Great.
Thank you.
Thank you very much for the very interesting Q&A. Kees, you have a question? Maybe you can put it on the Q&A section, please. And
no, only if there's time. Otherwise, I will rest my question.
Okay. Yeah. So then we better move on to the next case from Nefele, which is energy management in smart building and cities, from Alejandro Arias Jimenez. Alejandro, if you can share your screen.
Hi, everyone.
Hello.
Right. Okay, I'm sharing the screen now.
Yes, we can see.
Okay, perfect. Okay, so I'm Alejandro Arias, from a junior researcher from Odins. Well, I'm going to present NFL use case number 3, energy management in smart buildings and cities. First of all, I will give a short introduction to problems related to energy. Well, the first one is that the global electricity demand continues to rise as economies grow and population increase. This increase in demand overloads the existing electricity grids, especially during peak hours. Another problem is that governments worldwide are implementing stricter regulations to combat climate change. These regulations often include targets for reducing carbon emissions from energy production to reduce the carbon footprint. Another problems can be caused by external events that can have a significant impact on energy prices. For example, global pandemics or geopolitical conflicts can lead to fluctuation in energy demand and energy supplies, which could lead to higher prices. And also, many buildings rely on updated or manual system to track energy use. This means that many buildings do not have a real-time monitoring system, which will allow better control and optimization of energy consumption. And this is one of the main reasons why 30% of our buildings' energy is wasted. And this waste can result from inefficient heating, cooling, or lighting system. This use case number 3 for Nifel. This use case is led by Odins. We also have the support from Siemens and IBM, which are two companies that have a great relevance and importance in this sector. The main objective for this use case is to develop different advanced applications and services leveraging on the IoT to edge to cloud continuum and the virtual object stack, which is one of the main characteristics of the Nefele project. This allows for an energy efficient control actions of building equipment to improve energy efficiency and well-being. And in addition, this use case offers higher level application like object or person recognition and detection, and also provides some security features that Nefele will offer in the project, such as secure and authenticated access. In this application scenario, you can see that we make use of the IoT to edge to cloud continuum, or what we call the computing continuum. And in the IoT layer, we have the IoT devices, the sensors and the actuators. And then in the edge layer, we have the virtual objects, which are the digital counterparts of the physical IoT devices. And finally, in the cloud, we have the applications. We have the smart energy balancer and the management interface. In this case, virtual objects nodes will perform in intelligent energy-saving actions, not only based on the sensor measures collected by the IoT devices managed, but also the information and data coming from other nodes. This will drive the efficient use of renewable energy sources and the reduction of peak energies, of peaks in energy consumption. Also in this scenario, several temperature monitors and HVAC systems are controlled by the Smart Energy Balancer application. The objective is to control through the temperature and consumption sensors when the heating devices should be activated. To do this, decisions are made based on multiple devices that must be able to coordinate. The system will also offer a management interface that allows to indicate the parameters to be met by the system, such as the target temperature for each zone and the consumption limit established for the balancer, and also can be used as a dashboard for real-time monitoring. Thanks to the virtual objects and the possibility of composing them into more complex ones, it is possible to assign temperature sensors HVAC pairs, which makes it possible to define more complex and intelligent virtual devices at the first level, which are the composite virtual objects, 1 and 2, resulting in a system with HVAC with a thermostat. But on top of this 3 level, it is possible also to create a more advanced one that groups several intelligent air conditioning systems, which is the composite virtual object 3, that interacts with the smart energy balancer, being able not only to work on temperatures, but also to organize the switching on and off to limit the number of machines that are on at any given time, limit the power or prioritize one over the other, depending on the complexity or intelligence that we want to implement on the composite system. Finally, some of the characteristics that this use case offers are that it can be easily integrated with industry standard protocol systems such as Modbus or Z-Wave, ensuring compatibility with existing HVAC controls or lighting systems. Also, as I mentioned before, it offers real-time monitoring and intuitive dashboards, and also offers predictive analytics to anticipate energy demands, maximize efficiency and reduce waste. With all of this, your energy cost will be reduced, and you will save money. Also, you can improve with this. You can improve your equipment lifespan. There is a significant market demand to which problems I mentioned before in the first slide. Also, there are governments that are offering incentives for companies that invest in energy efficient technologies and practices. Finally, the stakeholders for the use case can be identified as local governments, building managers, energy communities, energy service providers, or security services. And that's all. Thank you for your
Great.
for your
Thank you very much. I take the chance to apologize. We are running a little bit over time. maybe we have time for one quick question. If there are any. Keith, please, one quick question.
Yeah, on stakeholders, you mentioned, let's say, the building owner, but in my view, there are many more stakeholders, which is the tenant, the service provider, the installer. So what's your view on how to deploy this? Because I think there are many more decision makers in this whole complex field of buildings.
Yes, this is like a resume. I mean, you can, like you said, there are a lot of more than just the building manager. So they're going to be more involved users in the deployment of this use case. But finally, what the main focus is for the building managers. I mean, you use like you said. There are a lot of more, but the main focus is for the building managers.
Okay, thank you.
Great, thank you. Then we quickly go towards the NEMO use case, smart energy and smart mobility. Now, Prasanth, if you can please present.
Hello, let me share the screen.
Yes, please try to be as close to the 5-minute mark as possible.
Yeah, I have a very short presentation. Okay, so can you see my screen?
Yep.
Yes.
Okay. So hello everyone, I'm Prashant from ASM, and I'm working for the R&D unit of ASM Terni. We are part of NEMO project. We are a distribution system operator based in Umbria, Italy. So coming to the NEMO project itself, to be short, NEMO is establishing an open source adaptable cybersecure meta operating system through leveraging existing technologies, and it is validated in 5 prominent industries: farming, energy, industry, mobility, and XR. So we are responsible for the smart energy trial. So coming to the use cases, we have a couple of use cases, a bit of background. So due to the energy transition and the adoption of green energy, the distribution network is facing challenges primarily due to the reverse power flow phenomenon. These imbalances could be voltage fluctuations, surges, and over and under voltages, current overloads. So, and coming to the impact of EV mobility adoption, the electric vehicles, yeah, they are a promising step towards reducing greenhouse gas emissions and transitioning to sustainable modes. But we need the cars need to be charged, which means we need more electricity available. So the strain is in the form of increased demand of electricity, which can lead to overloads and existing imbalances within the grid. However, with proper management and integration into grid's operation, EVs can play a key role in enhancing grid stability. So coming to the use cases, the first use case is smart grid flexibility. The objectives are to enhance power quality monitoring and artificial intelligence, machine learning based forecasting services, and improving grid visibility. So we use the advanced sensors to closely watch and maintain the quality of electricity in the grid, which means ensuring everything is running smoothly and efficiently, and also use the AI ML models to forecast production and consumption. which increases our understanding of the grid's condition in real time and exploiting flexibility. And coming to the smart mobility use case, the goal is to improve renewable energy sources load balancing via EV chargers and predict traffic flow, parking prediction via EV chargers and parking positions for mobility, and support citizens' eco-mobility in a smart city scenario, combining crowd sourcing into info and public transportation, weather noise data, along with historical data and analysis of CCTV cameras. So driver-friendly scenarios will be realized for this use case, and dispatchable charging of EVs based on RES demand response, along with human-centered smart micro contracts and micro payments. So the blockchain mechanism is demonstrated in this use case. So, okay, coming to the next slide. Okay, so in both cases, we will investigate advanced AI-based analytics to train models at different levels at the same time at AIoT level for identifying potential local grid discrepancies using already trained ML models, at edge cloud for applications such as protection, power quality, and partial discharge detection, and at cloud level to elaboration of streams or pre-elaborated data coming from different locations. So this is a short presentation of the use case. Thank you.
Great, thank you very much. I'm afraid we're really running out of time. Please use the Q&A section of the meeting to ask questions, and I would directly then go to the last use case, last but not least, as I said earlier. So that's Nebulous with energy and utilities windmill maintenance. Michal, please.
Okay.
Yeah, sorry to be late, Michal.
No worries, no worries. Okay. Can you see my screen properly?
Yep.
Okay, very well. So welcome everyone. My name is Michał Kłosiński. I represent Nebulous and windmill maintenance use case of TTA. So let's go into it. So what is it all about? Well, we do a visual inspection of the windmill blades, well, primarily this. So what we trying to identify are some damages that are happening to the blades over the time when the turbine is getting older and is being used. So they are rotating at fairly high speed, and there's a number of elemental factors and other things that might happen to the blade. So basically what we are trying to do is to locate those damages, identify them, say whether it's a flying object impact, whether maybe lightning strike, maybe leading edge erosion. Well, there's a number of those depending on how you classify them and what you want to observe on the blades. But they affect the performance of the blade. They need to be repaired with time. Yeah, we want to identify them, but also assess the severity and maybe find the location, I mean, say what part of the blade is affected. Based on the severity, you can decide whether it needs to be fixed quickly or maybe in the next maintenance period. Damage location is also important. I mean, the tip of the blade is more, it rotates faster, travels faster, so it's more, the damages there are more dangerous that close to the nacelle. So what's the process? We collect the data, we want to process it. So it used to be done manually, fully manually. So an analyst would go through the images, locate the damages, describe them, prepare the report, submit the report. Well, what we done years ago as a first step was to extend that process with automatic analysis using computer vision algorithms. So we are using some neural nets to identify those damages and suggest some things to the human. And in the end, the human makes the decision, makes some alterations to that classification and prepares the report. But we want to improve that process. You can imagine that for one blade, there are 4 sides. When we are taking pictures, we have 3 blades. For every blade is like 30 images, so 12 rather 30, we have 360 or something like this images per blade. times number of windmills, it's simply a lot of work and pretty tiresome work to do manually. So that's the background. So what we are really doing with Nebulous project? Well, we wanted to switch a bit the way we are processing that data. It used to be fully batch-oriented process. So first there was an inspection, images are being taken, uploaded to the cloud, then the processing is happening. What we changed in the process is that it's more real-time or almost real-time.
Sorry, Michal, maybe you want to be on the next slide, since I have seen. Okay,
well,
sorry.
We will come to that one second. So one of the main challenges that we are facing with the processing is, well, one of those is remote locations. It may be offshore in the water, or it might be amount of data. So what I mentioned before. So let's indeed go to the details of the inspection process. How we are operating right now. It's that first of all, the first step of the process is happening on the drone. So we do the quality assessment, we do blade part detection. It's not, well, it's useful also for the asset management systems, but it also can be used for autonomous flight mode. So there are two models running already on the drone, giving some feedback to the operator as well. So we can immediately assess the quality of the image that has been taken. I don't know, on the offshore turbines, there might be reflection of the sun from the water, and that image can be overexposed, for example. So that's what's happening. The first step, when the quality is okay, we are sending that to the computer nearby. It might be edge server, it might be laptop. Then we do first processing where we look for the candidate damages. We do, which is also has clearinghouse effect. So if there's no damage on the, or no candidate damage on the image, we can leave it on the edge device and do nothing with it. But if there is something to be classified, then we are making a crop and sending that to the cloud. So from single image, there might be multiple damages, so that work multiplies. That's why the rest of the processing is done in the cloud. But the first feedback can happen already in the edge. So where is Nebulous in all of that? Well, Nebulous provides the unified computation continuum. I mean, we do not really care about what models are running on the edge, which are running on the cloud from, well, we don't care. We do in a way, but we can easily switch from the edge to the cloud. So for example, if there's too much work to be done on the edge, maybe it's better to offload some of the traffic to the cloud. If there are some specific use cases, I mentioned remote location, there might be no internet connectivity, or maybe don't from the edge device, so we don't have immediate way of sending images. There might be a queue of data to be processed. In such a situation, we have a spike of the load as long as we want to finish in this more or less the same time. So we can provide more resources in such a case. So that is done also by Nebulous, at the same time optimizing the cost of the whole operation. So we don't want to over-allocate the resources, so we don't need to pay for it. It's mostly about the cloud. So that's how Nebulous helps us. And finally, why we are doing that? Well, first of all, improvement of the process within the inspection process itself. So quicker feedback. We are providing the information to the operator of the drone. There's no manual image upload. In general, the process is more smooth. But also, thanks to that whole framework and the way we are processing, we can change the steps. I mean, we can change that pipeline to something else. We can focus on some other aspects in the drone. So we are flexible in the way we are processing those images, and we can change that very quickly. Who can benefit from that? Well, of course, inspection companies that are our primary customers. We are providing the data processing platform for them, but also wind farm operators if they are doing inspection of their own. In longer term, we are thinking about other verticals. So there's plenty of opportunities where drone or some other IoT device plus edge and cloud processing is useful. The same principles, the same way of handling pipelines, but different models. And also going into sensor fusion around within an inspection process. So different type of cameras, additional scanners, additional sensors on the towers as well. Like microphones or vibrations or LiDAR on the gearboxes. So that's the long-term perspective or mid-term perspective for the project. And that's it. Thank you. I'm not sure if there's time for any questions. If not, then I will answer them on the chat.
Thank you very much. I'm afraid I've already eaten too much into EGI's presentation. Indeed, there's the Q&A section. Please, also for the use cases, please go on there and answer the questions. From our side, from BlueSpec side, just quickly, thanks again. Thank you very much for your active participation. Sorry for the overtime. And just a reminder to get in touch if you'd like to trial the ceiling tool, develop your corporate venture building, or introduce novel solutions into your processes, just the ones we have been discussing in this workshop. Thank you very much. Very sorry, Mark. I give the floor to you and your panel. Thank you.
Okay, thank you very much, Jose Luis. Let me just do a mic check. Can everybody hear me?
Yep.
Okay, awesome. So we are going to do a quick market validation for the top edge IoT use cases that we are finding in the energy sector. Next slide, please. This process is going to involve you, and I really hope you will stay with us for the next 40 minutes, and we're going to stay on time. And we're going to do this through Menti. So I'm going to re-display this QR code and these numeric codes on several slides so that you can log in and follow along with our questions. I know this is sometimes takes a minute or two when you're listening along, so I wanted to make sure to give you a heads up about that. If you could go to the next slide, please, Ilya. So our objective here is to first introduce what we're going to do. We're going to be reviewing market information for this sector. We're going to discuss a number of actions that we've developed and identified as potentially being useful to accelerate adoption in this market. We'd like to have an open discussion with you about your individual plans as participants in the market, about how you might implement edge IoT use cases. So who would you work with, what your business models would be. So we're going to ask a few questions about that, and then we'll bring it all together in a short conclusion and feedback session. Next slide, please. So very quickly, our validation process, we're going to talk about the market opportunities based on the best available data, get your feedback on this information. And we will use your feedback to fine-tune our estimates and then build this along with the same feedback in 4 other economic sectors into an overall market scenario, market pathway projection for the edge market. And these recommendations of actions will be presented to the various stakeholders that are affected. Next slide, please. So we'll start off by asking about who's here? Who are the participants here in this meeting? So if you could open up Menti, if you haven't already done that, the codes are there. If you could indicate what kind of organization you are, and maybe there's maybe none of them apply, but we're looking primarily for people who are active in the market in one way or the other as DSO, TSOs, different kinds of generation companies, perhaps taking roles in the energy, the emerging energy market, providers of various kinds, either in the energy market or another IT market player. So let me give you a moment to answer this question. And then we're now going to do the hard part for us, which is to switch who's going to display the results. So quickly, let's go to Johnny, who's going to share what the Menti results are. Awesome. We've got 6 response 7. Keep them coming, boys and girls. I love it. I'll give it a minute to settle. We seem to have reached a plateau of responses. So it looks like we've got about 12 people who are active participants. Oh, 15 coming in. A few more seconds. This is awesome. So we're seeing a lot of researchers, obviously, as well as people who are other IT market players, as well as IT market software players. So a very interesting mix. So I'll be very interested to see your answers to the rest of the questions. So let's go back to Aaliyah. So that we start off by estimating the total addressable market. So how many enterprises and facilities are that might implement the different use cases that we're talking about. And in the energy and utilities sector, there are roughly 15,000 enterprises who are probably big enough and have enough value added, enough profit to be able to afford investing in an edge IoT use case. There are a much bigger number of companies and organizations who are in this sector, but much smaller, so almost 250,000. Of those ones who are likely to be adopting, we make a very rough estimate that there are 3 facilities for the bigger ones and only 1 facility for the other ones. That gives us a total of about 30,000 potentially investing facilities in Europe, in the EU. So that's our initial estimate. And I want to just bounce this off of you. So if we could go to the next slide, please. Okay, so basically you're going to ask the question, you're going to answer the question in your own experience, is that estimate of about 30,000, 31,000 potentially adopting facilities, is that about right? Is it too low by various percentages? Is it too high by various percentages? So we're trying to get a bit of a gauge as to whether we're in the ballpark there. So if you could start answering, there we go. I think we're 2 people are answering. It's basically a little bit less. A few people are also saying it's a little bit more. So we're seeing a range of answers here. What I can't tell from this picture is how many people have answered. Johnny, do you have this information about how many people have answered? Because I want to stop when we get close to 17, because that's how many people answered the last one.
I don't have this information live, but I can check later on.
Okay.
Actually 7, no, it's actually visible on the very bottom. So 7 people have answered.
Oh, I'm not seeing it myself. So we'll give it a couple more seconds. If you can put your thinking caps on to, I realize this is not your daily business. You may not have this information, but if you have seen some information or have information from industry venues where you've gotten a feeling, this would be helpful to understand. Okay, so let's move on. This has been very helpful. Thank you very much. So Aaliyah, if you could pick the presentation back up. Next slide. There we go. So our colleagues in this project, IDC, developed a list of use cases that they were considering in the 5 sectors that we're examining in this project. And we've actually taken that list of use cases. We've done a little bit of refinement in exploring some of them in more detail, but essentially for the energy and utilities business, we have almost 20 specific use cases. So these are listed in not in any particular order. So I'll quickly highlight. We've got condition monitoring for fixed equipment. We've got tracking and optimizing mobile assets. We have smart meters, reporting of different kinds, enhanced grid monitoring. The actual smart grid is a few numbers down, E11. We have drone-based inspection. Monitoring of technician, the people who go out in trucks to solve problems with the energy system, smart building management, as well as the use of automated guided vehicles in special environments such as switch charge and substations. So I know this is a rather detailed list, but as you just eyeball this and look at this at a very high level, I'm hoping to get some feedback from you about whether you think these are about right or if there are some that are missing. So let's go to the next slide. We're going to ask you 3 questions. Nope, that's not it. First, are we missing any important use cases? So here you have an opportunity, if you see something, if you feel something that is not listed there, and we've reproduced it in the diagram in the slide, would you please answer that in? Or if you think that's a fine list, put in no and provide us with an answer. There's one no. What do the other 16 people think? Yeah, that's a good one. That's a fair point. Yeah, smart grid use case has many sub-use cases. I completely agree. It's very difficult for us to explore that. The same for smart meters, to be honest. Yeah, fair enough. Indoor environment quality monitoring. Interesting. Okay. Battery swapping. Some great ideas, new ideas. Okay, we'll just give it a couple more seconds. Okay, let's go to the next question, please, Johnny, and we'll stay with Menti. The next question is, are you considering or implementing use cases that are not on this list? So this is a very specific question. Are you considering or implementing a use case that's not on this list? This is not, can you think of one? It's, are you doing it? And you can answer no, so that's fine. I'm just going to give it a couple more seconds. Well, 2 responses. Yes. Well, I guess I was kind of hoping for something specific. So maybe we asked the wrong question. Well, maybe the 2 people who said yes, maybe they could tell us what they're thinking about in particular. I'd appreciate that. Okay, let's move to the next question, the last question. And in fact, we've already heard this from a couple people. So there we go. How many of you have other use cases related to EV charging? So this is mentioned as an additional point. And so this is your, do you have these use cases? And again, the answer is no or yes. That's fine. And they could, this is a category, as you say. Let's just deal with the category as a whole. So that's a yes or a no. Yes. Optimization. Thank you. Give it another second or 2. Security, good point. Okay, well, if you could continue to answer that, I'm going to move back to our presentation and move on to the next category of information, but you will be able to, if you have additional answers, you will still have information, you'll have an opportunity to put that in. So we've talked about the total addressable market. We've talked about the kind of use cases that might be implemented. Now we'd like to look at the question of adoption rates. So we're presenting 2 sets of information that were collected by, again, our partners at IDC. They had done a survey and they identified, they got answers from the energy and utility sector in terms of the number of the survey respondents who said they were already using a certain use case, already implemented one. And then there was a second number that said how many of them are planning to adopt or implement this particular use case. And here are the numbers. So the numbers already using, it's actually sorted in descending order, and it goes from a high of about 43% who are already using something in this area to about 20% saying that they are already using it. And frankly, I actually think these are a little high myself, but I want to get your views on this as experts in this area. The other aspect of this is how many are planning to adopt, and this is roughly what the annual adoption rate looks like. And here it ranges from kind of low, less than 1% per year, to in the case of automated guided vehicles, close to 5% of the surveyed responses said they were interested in implementing the automated guided vehicles. So let's now move to the Menti question, which is your feedback about these percentages. Johnny? Perfect. So you'll have two questions, and you can select your thoughts about whether you strongly agree or strongly disagree, or just disagree with the percentage of organizations that are using, who have already implemented, as well as the number who are adopting. So so far, for example, we're seeing, okay, sort of about right answer to slight agreement with the number who are currently using these implementing these use cases, and perhaps slightly disagreeing with the numbers of adopting. And I guess if we were had our thinking caps on, we might have asked the same kind of percentage question as before, to get a feeling for in which direction people were disagreeing. But we're still pretty much on track. I'm gonna give it one more second. Very good. So let's move on to the next question, please. Actually, let me double check. Yeah, we need to go back to Elia, please. If you could, you can continue to answer this question. Meanwhile, we're going to go back to Elia's presentation where we're talking about investment levels. Now here, we've attempted to estimate the investment levels per facility for each of these use cases. Now, this is a desk analysis. This is not something where we put it out for bid or had a crew of engineers putting together an estimate of what it would cost, but we did do some detailed analysis to figure out what we thought the cost of the gateway or the central portion of the use case might cost, and the cost of the various devices that would need to be installed. We also recognize that there are a lot of, shall we say, cloud or rental options that are being discussed in the market. We're assuming everything would be purchased, so just to keep things comparable. So what we're seeing in general is a fairly modest gateway investment or central investment. The major exception to this is diagnostics and incident detection from enhanced grid monitoring, which is a fairly high cost, similar for optimized oil and gas exploration and production, which is not really the people in this room, but it is one of the use cases that was considered by IDC. On the device side, we see a much different situation, and in particular, we see the smart meter application having a significant investment cost on the device side, the smart grid having a fairly significant device cost on the device side. The next in line is, again, this oil and gas exploration, roughly 600,000 euros per facility. So you see a range of facility investments, and I realize it's hard to sort of evaluate that as a overall, but I want you to sort of hold your fingers up and squint at it and give me a feeling, give me your feedback about whether you think these investment levels are about right. So let's flip over to Menti. The next Menti question will be investment levels and your views. So do these typical investments match the system costs that you have seen in your own planning? So based on your own experience and thinking about investing in these kinds of use cases, do these seem about right? Or would you disagree with them? So here again, we are getting the disagreement so far, and we don't yet quite have the quantified response. So this is, I guess, an oversight on our side. We'll ask this question in our open discussion. So any other answers on this? So one more second. Okay, so let's move to the next question. And this is kind of a different take on the same question. And this is a much more pointed question. Would your organization consider investment at this level? In other words, are these, if you're disagreeing with the prices, for example, on average, is that because you think they're more expensive, and therefore, and also, you know, if they were more expensive, would you be investing? And right now we're getting neutral answers about the level of interest that your organization might have in actually investing at these levels. Okay, one more second. Okay, we're going to jump back to the presentation now. Keep answering this if you have views on this. Aaliyah? So based on this, the information that we've presented so far, we've calculated what the annual market opportunity could be in each of these use cases in terms of sales, in terms of the money being spent on different use cases. And as you might imagine, the estimates are vary widely. Some are quite small, some are quite big. So let's look at the next slide, because we'll sort them by in descending order of market opportunity, market size. And here we see clearly that smart meters is the big opportunity. About 4 billion euros a year, with about 450 facilities making this investment every year at an average facility cost of about 4 million euros. And then for smart, and I must say that there are some different numbers there. So we'll just keep in mind that the math is a little hard to do mentally here. Smart grid is the next one in line, real-time analytics, about 1.6 billion euro opportunity. The automated guided vehicles appears to be very strong based on the information that collected by IDC and our own analysis. I don't know whether I'll be asking the question of whether you agree with this in general. Diagnostics and incident detection from grid monitoring. Pretty basic. Then we get into the small numbers: intrusion detection, location, tracking location of key movable assets, enhanced grid monitoring. So it's it falls off. The major ones represent the bulk of the market for sure. So let's go to the next Menti question, which is asking for your feedback in these areas. So are these estimates the right ones? In other words, do you strongly disagree with them? Do you think that they're about right? Do you think that they're correct? Or are you seeing a much bigger market, let's say, and you disagree with it, or perhaps a much smaller market? I can't imagine it being much smaller, to be honest, but perhaps that's the case. Okay, well, let's go to the next question, which is essentially a a variation on this, or it's the things we've missed. So here it's a type in answer. Which other opportunities would you have estimated to be bigger? So far, I'm not hearing from anybody. Perhaps all that's left are our, the in-house people. I don't know who's on the call still. I can't tell. Okay. It's an interesting circumstance. Okay, well, in the interest of time, I'd like to move on if we can. So I've talked about the overall market. Now the question is going to be, let's go back to the presentation from Aliyah. I've talked about the overall market. The thing we need to think about now is what's holding us back. So let's go to the next slide, please. Next two slides. There we go. So here we're thinking about the challenges and readiness factors that companies are facing as they consider investments. And when I say company, I mean even the public sector organizations that run some of these, for example, DSOs, many of them are public sector organizations. So there are essentially 5 factors that we've identified, and they're very broad categories. So technology readiness, is the technology available from vendors that's ready to be deployed to meet your objectives? The next one is your own internal challenges. In other words, and even as a supplier, you might be able to speak to this. Is your organization or the organizations you're dealing with, are they ready to adopt this use case or these use cases, or are there internal changes? In many cases, people are just not ready. They're not ready to make the changes to their own operations that adopting a use case would require to make it pay off. That's the next question, is do you see a payoff? Is there are the costs and the benefits are well understood, and is the return on investment clear? So that's the third challenge. Network readiness. So is the network in place for this? So we've talked about, for example, moving from GPRS and other capabilities or CDMA to 5G, and that's a transition. But 5G isn't available everywhere. It might not be available in a rural area or along the routes of some of the transmission lines or distribution lines. So 5G might not help you if it's not actually available in a particular area. So you may need to consider other network possibilities. And then lastly, data challenges. So there's already been a discussion about data sharing. I'm asking a more narrow question, which is, do you see as an organization that you have the data that you need to go with the information from the use case to make good decisions? Maybe it's there, or maybe it's not yet collected and you can't operate it. So let's go to the next slide, which will illustrate the results of from a survey on this, which talked about specific economic challenges, specific technology readiness, specific examples of customer readiness, for example, the lack of the needed skills or regulatory risks, and finally, in the network, the immaturity of 5G networks and devices. Next slide. Here are the results of that survey, just to give you a feeling. It's a little hard to read. I had trouble with getting the spreadsheet program to cooperate, but you can see that there's a range of these factors account for sort of 15 to 30% concerns on the part of many of the respondents. So my question now, and this is where we go to Menti, is what do you think? Which of these 5 main factors, could you please rank those 5 major factors in terms of what's holding you back? So this is a fairly straightforward question in terms of what are the biggest readiness factors for you in terms of adopting these kinds of use cases. Okay, well, I think we're at the point where there's nobody in the group. It seems like there's nobody in the group who's prepared to answer any questions. We don't have any. Oh, thank goodness. Oh, this is very helpful. I guess it took people time to sort things the way they wanted to. And Johnny, can you tell me how many people have answered? I can't tell.
We have 3 answers.
Okay, that's what that little number down to the lower right is? And now 4, okay. Okay, well, I think this is quite meaningful. I hope you will keep looking at this while we change back to the PowerPoint presentation. So for those of you who are still working on their answers, please continue to do that. So in order to overcome some of these challenges, and again, we didn't have your ranking, so we were making guesses a little bit. But some of the ideas that we considered was some of the use cases depend a lot on video processing, and they relate both to the inspection use cases and the intrusion detection use cases, as well as all the autonomous vehicle and automated guided vehicle use cases rely very heavily on the use of image recognition and the processing of images. So there may be a need to strengthen a center of excellence in video processing to apply to edge use cases, and this could benefit those certain kinds of use cases. Another possibility is a center of excellence in location tracking, where use cases are fundamentally tracking assets, mobile assets, high value equipment, etc., that can move around, maybe a large test device or test equipment, even employee safety monitoring. So this could be an area that could help give companies across many sectors some comfort and reliability in the solutions in this area. Another version is greater resources dedicated to applying digital twins to process management and optimization. We actually heard a lot of this in the presentations by the industry people, and there was discussion of this as well by the Meta OS projects that they wanted to look at this. But I think the next step is giving the users confidence that they are using the right digital twins and that the digital twins are properly calibrated and have been validated in the real world. So that may require some special resources. And then lastly, a couple of flavors of incentives to expand network readiness, such as interoperable edge node designs or capabilities to allow for federation or some kind of roaming of edge devices, which would mean that you weren't locked into a particular vendor or technology. So I'd like to turn the question now back to you and see if any of these resonate with you in terms of being able to address some of the readiness factors. You've talked about economic challenges and data challenges, so now let's see if any of these will solve some of these problems. And this is your opportunity to rank these as potentially being useful. And the ranking process seems to take a little bit longer based on the last slide, so we'll give it a moment. So I can't see, Johnny, how many responses we have. It's covered up by some convenient thing from Microsoft Teams. Can you give me that number?
It's 4 people at the moment.
I think we had 5 people respond a moment ago.
Yeah, previous slide was 7 people. Now we are 5. So yeah, there is still.
Okay, very good. Well, this is interesting that both the people who are responding are telling us that the top 2 actions would be to provide incentives to expand network coverage. So this is very interesting. So you can continue to answer, and let's go back to the slide presentation. And I want to ask some very practical questions. This should go very quickly, and we should be on time. So my question to those who are in the market and thinking about this is, how will you implement your top use cases? So next slide, please, Leah. There we go. So how will you implement your top use cases? So if you have plans, if your organization is planning on implementing something, how will you move forward? Will you move forward based on the people you have in-house, looking to your existing IT partners or telco partners or cloud partners? Are you looking for new people with the right kind of expertise, some kind of mix, or have you not thought about it? So let's go to the Menti question and get your feedback about kind of who your go-to is in terms of getting started on this. No, we're skipping this one. And it's a ranking, so I'll give people a moment to answer, since that seems to take a bit of time. Very interesting mix. Based on the few answers we've gotten so far, the most interesting thing is that there's a real split. You know, some people are using the people they have in-house, and other people are looking to brand new outside specialists. So this is very interesting. Okay, how many respondents do we have, Johnny?
5 people. So we are close to the plateau, which is arrived also before to 7.
Okay, well, let's, if you would continue to formulate your answer on that, and we'll go, I'd like to go to the next, actually, I can't let you keep going. So we'll quickly go to Aaliyah, and you can show the next slide. So here we have 2 versions of the question. So who's the most important person in terms of being an internal champion for you moving forward with these projects? So is it top management? Is it your tech people? Are your operations people? I know there are other choices, but we're sort of trying to make it simple here. And then the next question is ranking your top reasons for implementing these projects. So we already can see a clear return on investment. So we're moving forward, or we feel we're keeping up with the next guy. We feel we need to do this to keep up. Or finally, there may be a situation where you have to comply with regulations. So there may be somebody forcing you to do this. So let's go to the Menti for these 2 questions. Next question, there we go. Wait for a couple more answers. There's a third answer. Okay, and let's move to the next question, please. So an interesting mix of tech and operations. And then your motivation for moving forward. What's your biggest reasons for moving forward with these investments? Okay, thank you very much. Let's move on. I do want to finish almost on time. We have one more question. So let's go back to. Well, I think we can just move to keep on the Menti. So move to the final question, Johnny. So many companies have different ways of working. So I'd be curious to know, of those people who are answering on their behalf of their organizations, how you typically like to work. So pilots, proof of concepts, partnering with a trusted supplier. Maybe you are in the driver's seat and you set the specifications yourself. Or maybe you like to have more of a shared model, including for sharing risk. Okay, well, this has been very helpful. Let's go back to our slides, Ilya. There we go. So first, I'd like to thank everybody for participating in this and helping us to sort of work through, get some feedback on this information. It was a very critical step in our process, and I appreciate your sticking with us at the final hour of a long session. We are going to have a very similar discussion with 4 other sectors in our study in similar kinds of workshops and webinars. And we're going to bring all that stuff together into an overall analysis of the market pathways and scenarios that we'll be sharing with all of you and with the community more generally. And you'll have the opportunity to provide additional feedback throughout the process. So this has been tremendous. I really appreciate your attention to the questions and your attention to some of the details. If you have any particular questions, I think you're more than welcome to get in touch with us, and you can reach me at the email that it'll be shown on the next slide. So Elia, if you would move it forward to the next slide. Oops, I guess it hasn't been updated. I'll put my email in the chat for those of you who want to get in touch and maybe have an additional. I'd be more than happy to have additional discussions about some of this information. So thank you very much, and that's all from us. And we're 5 minutes over, which I appreciate your tolerance and look forward to speaking with you again. Anna?
I'm still on mute. Well, thank you for all the great input and for the people that managed to stay on for such a long workshop. I think now we all deserve a break, right? Looking forward to hear more. Thank you.